Welcome to the Snoozy Scientist, where we gently wander through the mysteries of science, one sleepy yawn at a time. Tonight, we're drifting along the fragile edge between existence and oblivion, the quiet space where life meets its end, and sometimes refuses to stay gone. In science, extinction means forever, the permanent disappearance of a species from Earth's living record. For centuries, that word has carried a kind of sacred finality, a truth we rarely question, that no matter how powerful, beautiful, or strange, every form of life eventually disappears, and most already have. By every estimate, more than 99% of all species that ever lived are gone forever. Extinction isn't the exception, it's the rule. It's how Earth clears its pages before new stories begin. But what if that rule isn't absolute? For decades, scientists have stumbled upon things that shouldn't exist, creatures written off as gone, but somehow still existing. Each rediscovery is a small miracle of survival, a reminder that life is far more patient and far more hidden than we imagined. It makes us ask questions that unsettle the very foundation of biology. If life can return after vanishing, what else have we misjudged? How many ghosts of evolution still move quietly through the shadows? And is extinction as final as we've always believed, or only an illusion written by our limited view of the world? Tonight, we'll travel through lost valleys, ancient oceans, and forgotten islands to meet the creatures that defied extinction itself. But before we begin, if you find peace in these gentle journeys, where science drifts like a lullaby, I'd be so grateful if you gave this video a soft like or tapped subscribe so that more curious dreamers can join us here. And if you'd like, let me know in the comments where you're listening from tonight and what time it is there. It's always such a joy to see how far this little sleepy corner of science can travel across the world. Now, take a slow, deep breath, let your body soften, and let's begin our journey into the strange moments when extinct animals came back to life. There is a quiet moment that settles over the mind when we begin to question what we think we know. It drifts in like mist, soft and almost weightless, yet it gently presses against the boundaries of certainty. In the last section, we wandered along the edge of extinction itself, touching the idea that even the most final truths can bend in ways we never expected. Now, we continue forward, moving deeper into the fragile space where knowledge meets mystery. For much of scientific history, the disappearance of a species seemed straightforward. When a creature could no longer be found where it once lived, when its calls no longer echoed through familiar valleys, when its footprints faded from the earth, scientists assumed it had reached the end of its long story. Extinction was the word placed gently over its memory, a quiet seal on a life that had slipped away. But declaring something extinct is never simple. It is not a moment, but a conclusion drawn from absence. Researchers search the landscapes where the species once thrived. They look for movement, sound, or even the faintest sign of presence. When nothing appears after years of watching and listening, a thought begins to settle that perhaps the story has closed. Yet this thought, no matter how carefully reasoned, is always shaped by the limits of our eyes, our tools, and the places we have looked. There are many reasons a species seems to vanish. Sometimes an entire population collapses after long struggles with changing climate, shrinking habitats, or pressures they were never built to survive. Sometimes the landscape reshapes itself, pushing life into corners where humans rarely wander. And sometimes our search itself falters. A creature might slip into a region we never examined, or move in ways we never anticipated. It might simply become quieter or rarer, leaving behind only silence where a name once lived. For centuries, overconfidence made these disappearances feel decisive. If a creature did not appear in the places where humans expected it to be, the conclusion was swift and firm: extinct, lost, gone forever. Scientists of earlier eras believed their understanding of the natural world was wider and deeper than it truly was. They could not imagine that entire species might be living unnoticed in places barely mapped or scarcely explored. Yet Earth is far more intricate than any catalog, far more secretive than any survey. The surface we walk on is only a thin skin stretched over a world of hidden spaces. Beneath the oceans lie trenches deeper than mountains are tall, places where sunlight never reaches. Beneath forests lie caverns that breathe with their own weather. Far from cities and roads rise mountain ridges that only a handful of people have ever climbed or even seen. In these places, life can linger long after science has written its farewell. It is here, in these forgotten corners, that one of the most humbling patterns in biology begins to appear, a pattern so surprising that it reshaped the way scientists think about disappearance itself. From time to time, a creature believed lost suddenly returns. A fisherman pulls an unfamiliar shape from the deep. A researcher hears a call in the canopy that has no match in any modern field recording. A ranger notices a shadow moving across a remote valley and realizes it is something that should no longer exist. These moments feel almost unreal, yet they happen often enough that science now has a name for them: Lazarus species. The phrase drifts into the imagination like a quiet story from an old book. It refers to organisms that reappear after being presumed extinct, living proof that life can hide in ways that defy expectation. The term carries no magic, only humility. It acknowledges that our understanding of the world, precise as it may seem, is shaped by what we have seen and by how much remains unseen. A Lazarus species is not a myth. It is a biological and historical reality witnessed again and again across continents and oceans. Every rediscovery reminds us that the boundaries of knowledge are far softer than we assume. Life has an uncanny ability to slip between those boundaries, to wait in silence, to endure in places untouched by human certainty. As we drift deeper into this story, we carry with us a new awareness. Extinction, as we name it, is often a reflection of our own limited reach, and the return of a species once thought gone is not a miracle in the supernatural sense, but a quiet lesson in humility, a reminder that the earth is far larger, far stranger, and far more patient than our maps or measurements suggest. What lies ahead are the tales of creatures who stepped out of extinction's shadow, not because they returned from the dead, but because they were living in the folds of the world we had forgotten to look into. Each one carries a story shaped by time, resilience, and the deep mystery that still moves through the natural world. There are moments in science when the past rises gently into the present, not through imagination or memory, but through flesh and quiet movement. After exploring how fragile our understanding of extinction can be, we drift now into one of the most astonishing rediscoveries ever recorded. It begins in the warm waters of the Indian Ocean, in a place where the line between ancient time and modern time slips into a single soft blur. Long before humans walked across open plains, long before mountains took their present shape, and long before the great forests of today ever rooted themselves, a strange lineage of fish lived in Earth's seas. Their bodies carried hints of a future world, with limbs that were not quite fins and not quite legs. These creatures belonged to an age shared with towering reptiles and enormous ferns, an age when the planet's rhythms were slower and its oceans stretched like endless blue kingdoms. Among these early swimmers was a creature that scientists believed had vanished during the Great Extinction that ended the time of the dinosaurs. In the fossil record, It appeared again and again, then suddenly stopped. For generation after generation of researchers, the coelacanth became a symbol of deep time, a chapter from the distant past that had closed forever. Museums held the stone remains of its ancient forms, each one a quiet reminder of a world long gone. For roughly 66 million years, there were no signs that this fish still lived. Its absence seemed complete. Textbooks described it as a relic of a vanished era, an evolutionary trail that ended abruptly. No one questioned this. The idea felt solid, like bedrock beneath the scientific imagination. Then came a quiet moment in the year 1938, a moment that would ripple through biology with the soft but unmistakable shock of revelation. A trawler near the coast of South Africa pulled in its nets, expecting the usual catch. Instead, nestled among the ordinary fish was a creature unlike anything the modern world had ever seen alive. It had a wide, ancient face and fins shaped like limbs, and its eyes seemed to hold the stillness of the deep. When scientists examined it, the truth settled in slowly, almost impossibly. The coelacanth, a creature believed extinct since the age of dinosaurs, was alive. The emotional wave that followed was gentle yet profound. It was not excitement in the loud sense, but a deep, quiet astonishment. A life form thought to belong only to stone had been breathing and swimming in the present all along. It was as if the earth had whispered from beneath the waves, reminding us that time moves in ways we cannot fully measure. Its body held secrets that reshaped evolutionary understanding. The coelacanth moved its paired fins in a rhythmic pattern, almost like a creature walking underwater. These fins connected to the body through structures that resembled the early foundations of limbs, offering a rare living window into the ancient journey from sea to shore. Its internal organs, too, carried echoes of a distant ancestry, a notochord in place of a fully formed spine, a vestigial lung tucked inside its body, a reminder of past environments. Its anatomy became a bridge between what once was and what life eventually became. Yet perhaps the most remarkable part of its story is how it survived unnoticed for so long. The coelacanth lives in underwater caves, along steep volcanic slopes, places where the ocean drops away in sudden cliffs of darkness. Sunlight barely reaches these depths. Temperatures fall, currents shift silently, and pressures rise until the water feels almost heavy enough to shape the creatures that dwell there. In these shadowed habitats, the coelacanth found refuge from the changing world above. As continents drifted and climates reshaped themselves, it stayed deep in the quiet, moving slowly in the cold blue stillness. Its survival was not a defiance of time, but a partnership with the environment that held it. The caves and canyons of the ocean became a sanctuary, a place where sprawling extinction events and shifting ages could pass by without touching it. While the world changed in storms of fire, ice, and upheaval, this ancient fish drifted through darkness, steady and undisturbed. Because of this hidden life, the coelacanth carried its story forward without need for witnesses. It remained unknown, unseen, and unimagined by generations of scientists who believed the fossil record had spoken its final word. Yet the ocean, vast and quiet, held on to the truth. Today the coelacanth moves slowly through the deep, its body illuminated only by the faintest shimmering of filtered light. It carries the weight of history, not as something heavy, but as something natural, like a gentle current flowing through its lineage. It is a living reminder that Earth still keeps secrets, patient and calm, waiting for the right moment to reveal them. And so we continue drifting forward, guided by the knowledge that even the most ancient stories can remain alive, tucked away in places where human eyes seldom wander. As we drift away from the silent depths where the coelacanth moved through blue darkness, our path rises gently toward a very different kind of hidden world. The air grows cooler, light softens, the deep ocean quiet gives way to the hush of wind sliding across high ridges and valleys shaped by ancient glaciers. We are carried now toward the far side of the planet, to a land where mountains gather the clouds and forests breathe beneath curtains of mist. New Zealand has always been a place where time moves differently. Far from the continents, its islands grew without the heavy footsteps of large mammals. Instead, birds became the architects of the land. They filled the forests with strange forms and gentle calls, and for countless generations they shaped an ecosystem that felt almost like a dream. Among these birds was a creature that looked as if it had wandered out of a forgotten story, a bright and heavy ground dweller with a deep blue body, green wings, and a strong red beak. It was known as the takahe. For a long time, the takahe lived quietly in the mountains and grasslands, far from the human world. But the land began to change. Introduced predators moved through valleys that had never known such hunters, and the takahe's numbers dwindled. As decades passed, its tracks faded from the landscape. People searched for it, hoping to catch a glimpse of its bright feathers or hear its soft, low call. Nothing appeared. The silence grew. Eventually, scientists declared that the takahe had vanished for good. For roughly half a century, the bird existed only in stories and in the delicate color illustrations kept in old field journals. Children learned about it the way we learn about creatures from long lost eras, with a distant sense of wonder that carries no expectation of return. The mountains of New Zealand held their secrets tightly, and the world accepted them. But Earth, as we have seen, does not always follow the paths we imagine, and in the year 1948, in a rugged and remote corner of the Fiordland region, the quiet truth of the takahe stirred once more. Fiordland is a place of deep valleys carved by ice, mountains wrapped in clouds, and winds that move through tall grasses like slow waves on an inland sea. Few people ever travel into its most distant reaches. The terrain is difficult, the weather shifts without warning, and the land itself feels ancient, as if it has long preferred solitude. It was here, after years of searching, that a small group of explorers stepped onto a valley floor surrounded by towering walls of stone, their boots pressed into thick tussock, the long golden grass that sways with the wind. The air was cool and carried the scent of damp earth. Somewhere above, a K called from the high ridges, and then, almost quietly, a movement rippled the grass. What emerged was not a rumor or a memory, it was a living taka. Its feathers shimmered with deep blues and greens that echoed the shifting colors of mountain lakes. Its strong beak curved gently downward, and its eyes watched with calm awareness. For a long moment, time seemed to soften. A creature thought absent for generations stood before the living world again. The rediscovery of the taka spread through the scientific community like a soft breath of disbelief. Not loud or dramatic, but steady and profound. A bird that had been given a final goodbye had survived in a place so remote, so untouched, that no one had known to look there. Its presence was a quiet reminder that mountains can protect life in ways we rarely understand. The region where the taka survived was shaped by steep slopes, cold winds, and sprawling fields of snowgrass. These valleys were difficult to reach, sheltered from many of the pressures that had threatened the species elsewhere. The bird had adapted to this harsh refuge, feeding on the tender bases of the tall grasses and nesting in places where few predators could follow. The land itself had become its sanctuary. The survival of the taka revealed something deeper than a simple rediscovery. It showed that mountain ecosystems can hold entire worlds within them, worlds that continue quietly even when science believes they have ended. In these elevated landscapes, life can move at its own pace, sheltered by ridges, protected by distance, and shaped by winds that have blown for thousands of years. For biologists, the return of the taka offered a rare chance to study resilience, not as an abstract idea, but as a living presence. It demonstrated how species can endure by finding refuge in hidden pockets of the world, places insulated from disturbance and change. And it reminded everyone who heard the story that extinction, especially in the most remote landscapes, is never a certainty drawn with a firm hand. Today, the taka still walks through the grasses of New Zealand, a living testament to a land that holds secrets beneath its quiet surface. Its story continues, shaped by conservation efforts and the patient rhythms of the mountains it calls home. And as our journey moves onward, the soft presence of this once vanished bird lingers with us, a reminder of how life can endure in silence, waiting for the moment when the world finally looks closely enough to see it again. From the cool mountain winds of New Zealand, our path drifts outward again, this time toward the vast shimmer of the Pacific. The ocean stretches in all directions like a great breathing blanket, rising and falling with the quiet rhythm of the planet. Out here, far from the bustle of continents, lie islands shaped by fire and time. Some hold forests, some hold birds found nowhere else, and some hold secrets that cling to stone in the thinnest corners of existence. One of these secrets belonged to a creature with a name that sounded almost like a joke whispered by sailors. The tree lobster. It was a large, glossy stick insect that once lived on Lord Howe Island, a small patch of land where seabirds circled cliffs and forests pressed close to the water's edge. For many years, this insect moved quietly through the branches of the island's shrubs and small trees, feeding and climbing with slow, careful confidence. Its dark body blended with the bark around it, and its gentle movements mirrored the sway of leaves in the evening breeze. But the early 20th century brought a disruption that rippled through the island's life. A shipwreck allowed rats to reach the shoreline, and the ecosystem, unprepared for these new predators, began to unravel. Within only a few years, the tree lobster disappeared. There were no more sightings, no more rustlings on leaves, no more silhouettes against the dim forest light. By 1918, it was declared extinct. The forests grew on without it, carrying the quiet absence of a creature that had once shaped the rhythm of its nights. For decades, the insect existed only in old records and preserved specimens, its story folded into the long list of island species erased by sudden change. Scientists considered its loss complete. There seemed to be no place left for such a large, vulnerable insect to hide. Yet far to the southeast of Lord Howe Island rose a jagged shape that pierced the surrounding sea. Ball's Pyramid, a narrow volcanic spire, tall and sharp, standing alone in the emptiness. Its cliffs rose like dark blades from the water, and its slopes were so steep that very little life was expected to survive there. It seemed an unlikely refuge, a place formed more by wind and salt than by gentle habitats. Still, stories have a way of lingering. Fishermen occasionally spoke of strange insect droppings on the few hardy shrubs clinging to the rock. These signs were brushed aside as curiosities. The idea that a species thought gone for decades could cling to existence on a sheer volcanic tower felt too improbable to consider seriously. In the early years of the 21st century, a small team of researchers journeyed to Ball's Pyramid to investigate. The climb was difficult. The wind pushed hard at their bodies. The rock beneath their feet was sharp and unpredictable. As night fell, they moved carefully along ledges where only a few plants managed to survive. And then, beneath one of the tiny shrubs, they found them. Not fossils, not fragments, living insects, large, smooth, and shining in the beam of their lights. The tree lobster was alive. The moment settled in the air with a quiet weight. Here, on a spire of stone rising from the Pacific, the insect had endured. Only a small group remained, tucked into the only vegetation the island offered. They sheltered beneath a single patch of shrubs, navigating the narrow cracks of the rock, surviving where no one had imagined survival was possible. As scientists surveyed the area, they counted only about 24 adults, a number so small it felt like the thinnest thread between existence and oblivion. But that thread held. With great care, conservationists collected a few individuals to begin a captive breeding program. The insects adapted with surprising ease to their new environment, and the numbers began to rise. What started as 2 dozen survivors slowly grew into hundreds, then thousands. Each new generation carried the quiet resilience of that lonely volcanic refuge. Even with careful observation, there remained a lingering disbelief. Could these insects truly be the same species that vanished from Lord Howe Island almost a century earlier? The thought felt magical, almost unreal. Yet science relies on evidence, not wonder alone. Researchers turned to DNA, examining the genetic patterns that tie living beings to their histories. The results were unmistakable. The insects from Ball's Pyramid matched the preserved specimens of the Lord Howe Island stick insect. They were the same. A lineage thought erased had simply shifted its story to a different, harsher stage. With that confirmation, conservation efforts deepened. The insects were bred with tender precision in laboratories and sanctuaries across the world. Their offspring learned to cling to branches, to move slowly in the safety of dim enclosures, and eventually to thrive well beyond the tiny patch of shrubs on Ball's Pyramid. Plans began to restore them to their original island once the invasive predators could be controlled. Slowly, hope moved alongside the science. Today, these insects continue to recover, their numbers a soft echo of what once was lost. They carry a story shaped not by strength or prominence, but by endurance on the very edge of possibility. From a lonely volcanic spire in the heart of the Pacific, they emerged again into the world, reminding us that life often finds refuge in the places we overlook. And as the ocean winds drift past Ball's Pyramid, brushing against stone that has witnessed so many forgotten years, the tree lobster's quiet persistence becomes part of the long, gentle dream of survival that shapes our journey onward. The ocean winds that carried us across the Pacific begin to fade as we move inland again, this time toward a continent shaped by heat, silence, and vast horizons. Australia stretches outward like an ancient canvas, its colors shifting softly from gold to red to deep twilight blue. In these wide lands, sound carries differently. It drifts, thins, and sometimes disappears entirely. Even the wind feels older, as if it remembers stories that have long slipped from human memory. It is in this quiet world that one of the most mysterious birds on earth once lived its hidden life. A small green parrot with soft yellow markings, round wings, and a gaze full of calm alertness. It was known as the night parrot, a creature that moved through the desert at dusk, gliding close to the ground the way a thought moves through the edge of sleep. For many generations, it was seen only rarely, then, eventually, not at all. More than 100 years passed without a confirmed sighting. In that time, the night parrot became something halfway between a fact and a legend. Old stories from early explorers described a bird that called from the shadows just after sunset, a faint chime-like sound that carried over the spinifex grass. But as decades slipped by, even those stories began to fade. Scientists feared the bird had quietly disappeared, swallowed by drought, predators, and the long, sweeping pressures of change that often reshape desert life. The absence stretched so long that conservationists whispered about the night parrot with a kind of reverent uncertainty. It was not declared extinct with confidence, because no one had truly searched every corner of the outback. Yet it seemed so unlikely that a bird could survive unseen in such an open land. The desert was vast, but it offered little hiding space, or so it appeared. Deserts, however, hold secrets of their own. What seems empty is often full of hidden shapes. Spinifex grass grows in dense, spiky mounds where small creatures shelter from the heat. Salt lakes stretch like pale mirrors, hiding burrows along their edges. Flat stones lie scattered across the ground, concealing tiny tunnels beneath them. Much like the deep-sea caves that protected the coelacanth or the rocky cliffs that guarded the tree lobster, Australia's interior held pockets of life that escaped notice simply because no one thought to look closely enough. The difficulty lay in more than distance. The night parrot was quiet, careful, and mostly nocturnal. Its plumage blended perfectly with desert vegetation. It flew low and swiftly, leaving little trace behind. Even when researchers walked through its suspected habitats, the bird slipped away before they arrived, leaving only silence in its wake. Modern technology that worked well for tracking many species seemed useless here. The bird was too small for traditional surveys, too shy for camera traps, and too rare to appear often enough for easy detection. Still, whispers persisted. Occasional clues appeared, fragile like footprints in soft sand, a feather found on a remote cattle station, a half-believed sighting from a traveler moving across a lonely road at dusk. None of it proved anything, yet none of it fully closed the door either. Then came the year 2013, when patience met possibility. A team of dedicated researchers decided to approach the mystery from a different direction. Instead of looking for the bird with their eyes, they listened for it with new tools designed to capture faint sounds across large areas. These devices could sit quietly through the night, absorbing every chirp, whistle, and whisper carried by the desert wind. They recorded thousands of hours of nighttime soundscapes, creating a sonic map of places where human presence was almost non-existent. As the nights passed, the machines heard insects, shifting grasses, and the soft steps of mammals crossing the sand. But one night, among the subtle layers of sound, something unusual appeared. A short, bell-like note, repeated with a pattern that matched descriptions written long ago. It was faint, as if coming from far across the desert, but it was clear enough to stand out. When the data was analyzed, the researchers realized what they had captured. It was the call of the night parrot, not a memory, not an echo from the past, but the clear, living voice of a bird thought lost for more than a century. The discovery felt gentle yet deep, like the lifting of a curtain that had remained drawn for far too long. Guided by those recordings, the team returned to the region. They moved slowly through the dark, stepping around spinifex clumps and listening with careful attention. And there, in the soft glow of their lights, they finally confirmed it. A living night parrot, perched quietly among the grasses, blinking back at the world that had forgotten it. Its survival revealed not only the resilience of the species, but the hidden complexity of Australia's desert ecosystems. The night parrot had found shelter in places where dense vegetation created tiny labyrinths of safety. The spinifex mounds, sharp and tangled, formed natural fortresses that predators struggled to enter. These fortresses allowed the bird to slip into the deeper folds of the landscape, where heat softened, shadows deepened, and the world felt still. Even today, the night parrot remains one of the most elusive creatures on Earth. Its rediscovery reminded scientists that even with advanced tools and satellites mapping the globe, life can escape our notice simply by knowing its environment more intimately than we ever could. The desert, vast and warm beneath the stars, had protected its quiet secret until the world was finally ready to listen. And so we drift onward, carrying with us the soft echo of a bird that sang again after a century of silence its presence woven into the gentle and ever unfolding story of life's persistence. From the quiet glow of the Australian desert, our journey follows a gentle shift across the globe, carried by warm winds and the slow turning of the planet. The landscapes beneath us soften, then sharpen, then settle into the dry heart of South America. Here, in the vast Chaco region, the world feels old in a different way. Dust rises slowly from the ground. Thorny shrubs twist toward the sun. Heat gathers on the horizon like a distant mirage. The Chaco is a place where silence is shaped not by emptiness, but by endurance. Life here moves with caution, conserving energy as it threads through forests of spines and sand. It is in this rugged and ancient environment that one of the most startling rediscoveries of the 20th century quietly stepped back into the living world. For many years, paleontologists believed that a particular lineage of hoofed mammals, the peccaries, had once included a large, sturdy species known only from fossil remains. Those fossils told a simple story. They were found in sediments dating back to the late Pleistocene, a time when giant sloths wandered the Americas and huge predators stalked the plains. The bones showed an animal built for survival in a world colder and wilder than our own, a world shaped by Ice Age rhythms. Yet the fossils ended without a clear trail into the present. There were no modern sightings, no remains from recent centuries, nothing that suggested the species had survived past prehistoric times. By the early 20th century, scientists had fully accepted its absence. The animal belonged to the past, a quiet puzzle sealed in stone. Museum drawers held its bones, labeled with dates and locations. Students studying paleontology learned about it the way one learns about mammoths or saber-toothed cats, creatures forever trapped in the deep freeze of ancient time. But the earth often keeps its stories folded in ways that surprise even the most careful experts. In the year 1974, in a remote corner of the Paraguayan Chaco, a group of researchers encountered a small herd of animals moving slowly through the dry brush. At first glance, the animals looked like familiar peccaries, with bristly coats and snouts that lifted curiously at new scents. Yet there was something unusual about them, something that tugged at the edge of recognition. Their size, their proportions, the shape of their heads, and the structure of their hooves carried an echo of something known only from fossils. As the scientists observed more closely, a quiet astonishment settled over them. These animals matched the ancient bones found in Pleistocene deposits. They were, in every meaningful way, identical to the species believed extinct for thousands of years. The Chacoan peccary, long thought to be a relic of the Ice Age, was alive. It walked with a steady gait, its hooves clicking softly on the cracked earth. Its ears flicked toward distant sounds. Its dark eyes reflected the pale light of the sun. This was no ghost from prehistory, no creature resurrected through imagination or error. It was a living bridge between the world of the past and the world of today. The discovery shook paleontologists in a gentle but undeniable way. The fossil record, usually so reliable, had missed something important. An entire species had slipped through the centuries, hidden by the remoteness of the Chaco, moving through thorn forests so dense that even modern expeditions struggled to pass through them. What had been assumed extinct was, in truth, simply elusive. The Chacoan peccary's survival offered a window into conditions that shaped mammalian life during the late Pleistocene. Its body still carried the adaptations that allowed it to endure harsh climates, including specialized airways that helped it tolerate dust and heat, and hooves suited for navigating dry, uneven terrain. Even its social behavior, with herds forming tight-knit groups, seemed rooted in an older world where cooperation meant survival against larger predators. For evolutionary biologists, the implications were profound. The species demonstrated that extinction events were not always as absolute as they appeared. It showed that lineages thought long gone could persist in isolated environments where human eyes rarely reached. It forced a re-examination of the fossil record, reminding scientists that absence in geological layers does not always reflect true absence in the living world. Sometimes it reflects the limits of discovery, the scattered nature of preservation, or the vastness of habitats that resist exploration. More quietly, the peccary reaffirmed a truth shared by many Lazarus species. Life finds refuge in hidden corners. The Chaco, with its thorny landscapes and shifting temperatures, had become a sanctuary. The dense vegetation shielded the peccary from outsiders. Seasonal floods, extreme heat, and the difficulty of travel kept most people away. In this rugged place, the species continued its ancient rhythms, unaware that the world believed it gone. Today, the Chacoan peccary still roams the forests and scrublands of Paraguay, Bolivia, and Argentina. Its presence is subtle, its movements soft, its life shaped by landscapes that have changed little since the Ice Age. Conservation efforts work to protect it, yet the animal carries with it a quiet strength that speaks of deep time and long endurance. As we drift onward in our journey, the image of this living fossil lingers in the mind, a creature that stepped gently out of the past, reminding us that Earth's timeline is not a straight path, but a woven tapestry of survival, disappearance, and return. The story of the Chacoan peccary guided us through thorny forests, shaped by the deep memory of the Ice Age. Now, the world around us shifts once more. The air warms, light thickens, colors grow softer and greener. We drift deeper into the ancient landscapes of Australia again, though this time not into the open desert. Instead, the path leads us toward a hidden place wrapped in secrecy and cool shade. It is a place untouched by time, tucked between cliffs carved by water and wind. Australia holds many forests, but some are more than forests. They are echoes, faint yet alive, of worlds that existed far before humanity. One of these echoes lives in a small canyon so isolated that even experienced rangers had never thought to look inside it. The walls of the canyon rise high, with their stone faces streaked by centuries of rainfall. Ferns cling to the rock. A thin slice of sky hovers above like a quiet, distant ribbon. Within this natural enclosure, air flows differently, cooler and heavier, as if it has been drifting here for millions of years without ever leaving. It was in the year 1994 that a park ranger, moving through the rugged wilderness of Wollemi National Park, stepped into this canyon. He had no reason to expect anything unusual. The region was known more for its cliffs than its secrets, yet as he descended into the sheltered valley floor, he noticed a stand of trees that looked both familiar and entirely unknown. Their bark was strange, bubbling like hardened foam. Their branches held clusters of long, flat needles that caught the filtered light in an unusually soft way. Beneath them, the ground felt ancient, covered in leaves that seemed to belong to a forgotten era. He collected a small sample, carrying it out of the canyon with quiet curiosity. When the leaves reached researchers, the reaction was slow and almost disbelieving. The tree resembled something known only from fossil records, something that had not existed on Earth for around 90 million years. The fragments matched the remains of ancient pines that lived during the time of the dinosaurs, trees that had vanished long before birds evolved into their modern forms and mammals spread across the continents. Yet here they were, living quietly in a canyon within reach of a modern city. Not fossils, but breathing trees with resin, seeds, and strong, silent trunks. They were later named the Wollemi pine. The scientific community reacted much like it had when the coelacanth first rose from the depths. The feeling was not loud celebration, but a soft astonishment, the kind that moves through a room like a breeze shifting the curtains. A tree from the Cretaceous period, alive through ice, fire, and continental drift, had survived into the present age. And not just one or two trees, a small, secluded community lived in that canyon, holding on to life through countless generations. Their survival offered a glimpse into Earth's deep botanical history. The lineage of the Wollemi pine once spread across ancient supercontinents, where giant herbivores rubbed their sides against its bark, and insects older than most modern species crawled along its branches. When climates shifted, many forests vanished. Yet this one small group endured, protected by the canyon's isolation, preserved by the microclimate created by stone walls and narrow passages of sky. These trees held more than wood and needles. They held DNA that had traveled through time for almost 100 million years, untouched by the evolutionary changes that transformed so many of Earth's other plants. In a world where species continually adapt, shift, or disappear, the Wollemi pine had remained steady. Its genetic code became a library of the past, carrying within it the patterns and possibilities of a vanished landscape. Researchers studied the trees with gentle thoroughness. Each branch revealed clues about prehistoric ecology. Each cone held seeds that echoed an ancient design. The very texture of the bark told a story written long before rivers took their current paths. The discovery also raised questions about the fragile line between survival and extinction. The species had persisted because the canyon shielded it from fire, disease, and change. But its numbers were small, so small that the entire species could have been erased by a single lightning strike or a spreading fungus. Because of this, conservation efforts surrounded the canyon with secrecy. The location was kept hidden to protect the trees from curious visitors, invasive species, and any disturbance that might threaten their delicate world. Meanwhile, horticulturists worked to grow new Wollemi pines in controlled environments, spreading their lineage beyond the canyon for the first time in millions of years. Seedlings eventually found their way to botanical gardens and private homes, allowing people around the world to hold a living fragment of deep time. Today, the original grove still stands where it was found, carefully monitored and protected. The trees rise quietly in their sheltered cradle of stone, touching the air of the modern world with leaves shaped by ancient winds. Around them, the canyon remains as still as ever, a place where time folds into itself and where the boundary between past and present feels almost transparent. As we leave this hidden valley, the Wollemi pine lingers in the imagination, not as a relic, but as a steady presence that reminds us how much of Earth's history lives in silence, waiting patiently for the moment when someone finally steps close enough to see it. From the cool shadows of the hidden Australian canyon, our path drifts westward across the Pacific once more. The sky brightens, the air grows salty, and the ocean spreads beneath us like a vast sheet of shifting blue glass. Ahead lies a scatter of islands born from fire, rising from the sea in dark shapes that seem both young and impossibly ancient. These are the Galapagos, a place where evolution feels close enough to touch, and where stories of survival follow strange and patient rhythms. Each island in this archipelago carries its own personality. Some are green and soft with moisture. Some are sharp with lava fields, their surfaces cracking under the sun. Life here has always been shaped by solitude. Creatures that found their way to these distant rocks adapted in unusual ways, slowly becoming parts of landscapes untouched by the familiar patterns of larger continents. On one of the harshest of these islands, Fernandina, the world feels almost unfinished. Black volcanic stone stretches outward in rippling waves, hardened into strange forms by eruptions that shaped the land again and again. The ground is warm beneath the sun, fractured by centuries of lava flow. Very little grows here, yet the island holds a quiet power, as if every stone remembers the fire that created it. It was on this island that a particular tortoise species once lived. The Fernandina giant tortoise was known from a few specimens collected in the early years of the 20th century. The last confirmed sighting took place in 1906, when explorers recorded a tortoise moving across the dark rock. After that, the trail faded. Search after search revealed nothing, not a shell, not a track, not even a hint of its presence. As decades passed, the absence deepened. Scientists assumed the tortoise had slipped into extinction, perhaps unable to survive the island's unpredictable eruptions or the changing climate of the region. The Galapagos giant tortoises became symbols of conservation, yet this particular species was spoken of gently as a memory of what once roamed the volcanic slopes. Still, something about Fernandina left a door slightly open. The island was rarely visited due to its challenging terrain and ongoing volcanic activity. It was a place where heat shimmered off the rocks in waves, where deep cracks could swallow footsteps, and where the land seemed to shift underfoot in slow, unpredictable ways. If any species could vanish without truly disappearing, it would be one living in a place like this. Then came a day more than a century after the last recorded sighting. The year was 2019, and a team of researchers made the difficult journey to Fernandina's interior. They moved carefully across the scorched landscape, watching the ground for safe pathways between the twisted sheets of black lava. The air carried a faint scent of minerals, and in the distance, the quiet rumble of the island's restless core pulsed beneath the surface. As the team crossed a stretch of rock, they noticed something that did not match the hard angles of the lava: a slow, steady movement, a shape rounded like a hill, yet shifting with life. The researchers approached with cautious hope, their steps light on the uneven ground. There, resting against the volcanic stone, was a living Fernandina giant tortoise. Her shell was weathered and strong. Her skin carried folds that spoke of many quiet years. She moved with the deliberate grace of an animal shaped by time rather than haste. In that moment, the island's silence seemed to hold its breath, allowing the presence of this ancient creature to settle gently into the world once more. The tortoise was later estimated to be more than 100 years old, having likely lived through eruptions, droughts, and the long solitude of an island that rarely offered comfort. Her survival felt woven from the same forces that shaped Fernandina itself: the same heat, the same resilience, the same quiet endurance. The rediscovery was not simply a botanical or zoological surprise. It was a glimpse into how isolation can shield life in unexpected ways. Fernandina's harsh volcanic terrain created barriers that protected the tortoise from predators and human disturbance. The very hardships that made the island difficult for researchers to explore may have been the same forces that preserved her lineage for so long. Genetic studies later confirmed her identity, connecting her to the tortoise specimens collected more than a century earlier. Her DNA carried the story of a species that had seemed lost, yet continued its slow journey across an island shaped by fire. She became a living bridge between past and present, much like the Wollemi pine or the Chacoan peccary, except this bridge moved on ancient limbs, leaving gentle tracks in the dust. Efforts began to locate more individuals, though none were immediately found. Still, the discovery of even a single tortoise offered hope. Life has a way of enduring in the narrowest spaces, and Fernandina's labyrinth of lava provides many places where quiet creatures might hide, waiting unobserved for generations. Today, her legacy endures through conservation programs that aim to protect and restore the species. The island remains a place of mystery, its volcanic silence holding the possibility of others like her, living in the hidden folds of stone that stretch beneath the equatorial sun. As we drift onward, the image of the tortoise remains with us, a lone traveler across a black volcanic landscape, carrying with her a lineage that survived both fire and time. Her story folds seamlessly into our growing understanding that extinction, especially in the farthest corners of the world, is not always as final as it seems. From the volcanic stillness of Fernandina, our journey lifts once more across the ocean. The waves stretch beneath us like rippling sheets of blue silk, and slowly, the shape of another island rises from the horizon. This time, our path drifts toward the Atlantic, where the Canary Islands sit between continents, holding stories shaped by isolation, wind, and the long patience of time. La Palma is one of these islands. It rises steeply from the sea, its cliffs rising like dark curtains around a heart of forests, ravines, and sunlit slopes. The land is alive with contrasts, from volcanic rock, still warm beneath the surface, to soft green terraces carved by ancient farmers. Clouds gather along the ridges, then drift gently down into deep barrancos, the island's narrow valleys that feel as if they lead back into forgotten ages. Long before modern travelers arrived, La Palma was home to a remarkable lizard. It grew larger than most of its relatives on the mainland, its body long and strong, its head broad, its tail sturdy enough to help it climb rocky ledges. Early settlers described glimpses of these lizards, noting their size and the way they sunned themselves on warm stone. But as centuries passed, the stories faded. The lizard was hunted, disturbed, and pushed out of the places it once thrived. Eventually, no one saw it anymore. For 500 years, the La Palma giant lizard was believed to be gone. Its memory lingered only in scattered descriptions and fragments of bone, occasionally uncovered in old deposits. Scientists assumed that human arrival had sealed its fate, as had happened with so many island species around the world. The loss seemed complete, carried by time into silence. But islands rarely surrender their secrets quickly. Their isolation creates pockets of survival, places where species can hold on long after they seem to have vanished elsewhere. These landscapes, shaped by cliffs, hidden coves, and difficult terrain, act almost like quiet, time capsules. Creatures that disappear from familiar paths sometimes retreat into unreachable pockets, continuing their ancient rhythms far from human sight. In the year 2007, a team of biologists exploring one of La Palma's remote coastal areas noticed something unexpected. The rocks were steep and jagged, piled along the shore where volcanic cliffs met the sea. Few people visited these edges of the island. The waves crashed below, sending thin veils of mist over the stones. And perched on a sunlit ledge, half hidden in shadow, was a large lizard. It was not small or shy like the common lizards known across the region. It was sturdy, long-bodied, and moved with a deliberate calm that echoed stories written long ago. As the researchers watched, the lizard lifted its head toward the warmth, revealing the broad jaw and strong scales described in old accounts. The scientists held their breath. The animal matched the lost species from the island's past. Carefully, patiently, they observed more. More individuals emerged from crevices in the rocks. A small population, clinging to survival on a rugged cliffside that few people ever approached. The La Palma giant lizard, thought extinct for half a millennium, was alive. The discovery brought a quiet realization about the nature of islands. They do not simply preserve landscapes. They preserve time. Each valley, each cliff face, each isolated rock shelf can become a refuge where ancient lineages linger in silence. Evolution slows in these pockets. Disappearances pause or take new shapes. The world beyond may change rapidly, but an island can stand steady, holding on to life long enough for rediscoveries to be possible. The survival of the giant lizard revealed how fragile and resilient island ecosystems can be at the same time. Their isolation shields species from outside pressures, but it also makes them vulnerable to even small disturbances. When a species disappears from most of the island, one remaining pocket can be enough to keep its story alive. Yet that pocket can be easily lost without protection. This rediscovery became a driving force for conservation on La Palma. Researchers and local authorities began studying the lizards carefully, mapping their habitat and assessing the population's stability. Plans were set into motion to protect their cliffs from disturbance, to restore ecosystems, and to ensure that invasive predators could not reach the surviving colony. Captive breeding programs began, offering a path to rebuild numbers and possibly return the species to safer regions of the island. More importantly, the rediscovery shifted how people viewed the islands themselves. What else might be lingering in hidden folds of rock or deep ravines? What creatures have slipped out of our sight, but not from existence? The La Palma giant lizard became a symbol of patience, resilience, and the quiet surprises held by places shaped by isolation. Today, the lizards continue their slow, sunlit lives on the cliffs that saved them. They climb across dark volcanic stones, warmed by the afternoon light. They slip into cracks when clouds drift into the valley. They exist in a space where past and present touch lightly, where 500 years of silence came to an unexpected end. As we move onward from La Palma's rugged edges, the image of the lizard on its rocky perch stays with us, a small reminder that the world still holds stories that have not yet been told, waiting quietly in places shaped by wind, stone, and time. From the sunlit cliffs of La Palma, where a lizard stepped softly back into the world after centuries of silence, our journey turns eastward. Across the ocean and over continents, the land below shifts from deep blue waters to wide deserts, then to fertile plains and winding wetlands. The air becomes warmer, heavy with the scent of reeds and still water. Eventually, we arrive in a place shaped by marshes and birdsong, a place where patience and silence move together through tall grasses. This is the Hoola Valley of northern Israel. The Hoola Valley is a landscape of water and earth interwoven. Shallow lakes reflect the sky like ancient mirrors. Reed beds sway with the slightest breeze. Migratory birds rest here during their long flights, filling the air with gentle calls. But beneath the calm surface, the valley has experienced great change. In the mid-20th century, a large part of the wetland was drained in an effort to reclaim land for agriculture. The marshes that had existed for thousands of years shrank into narrow strips of habitat. Many species disappeared as their homes dried and fractured. Among the creatures believed lost was a small amphibian known as the Hoola painted frog. It had been recorded only a few times in the 1950s, described as a dark, stout frog with tiny spots and a quiet disposition. When the wetlands were drained, the frog vanished. For decades, hikers and scientists searched for any sign of its presence, yet the ground remained silent. Eventually, the frog was declared extinct, another casualty of a wetland transformed too quickly for life to adapt. As years became decades, the Hoola painted frog became a symbol of what had been lost. Biology textbooks listed it as the first amphibian species to go extinct in modern times. Conservationists sometimes mentioned it when speaking about the delicate nature of wetland ecosystems, those transitional places where land and water share a shifting boundary. The frog's absence felt complete, almost absolute. But extinction, as we have seen across our slow journey, is rarely as straightforward as it appears. In 2011, a park ranger walking through a newly restored patch of wetland noticed something unusual near the muddy edge of a small pool. He bent down, swept away some leaves, and saw a frog. Its colors, its shape, the tiny speckled pattern on its back, all matched the illustrations of the long-lost species. The ranger paused, unsure, then gently captured the frog to show the experts who studied the area. When the frog arrived in the hands of researchers, a soft disbelief settled in the room. It looked like the Hoola painted frog. It moved like it. It matched every known detail, yet no one had expected such a creature to still be alive after half a century of silence. The frog was examined carefully, then returned to the wetland. Over the next months, more individuals were found, hidden in patches of restored habitat that had only recently been brought back to life. The rediscovery was remarkable enough on its own, but the story deepened when scientists analyzed the frog's genetics. The results revealed something quietly astonishing. This was not just a rare frog that had reappeared, it was the only surviving member of a lineage that stretched back nearly 30 million years. That lineage had once included many species spread across the region during ancient geological eras. Over time, climate shifts, habitat changes, and natural pressures had narrowed the group until only one species remained, the Hoola painted frog. When the wetlands were drained, it had seemed the last chapter of that lineage had closed, yet the frog had endured, sheltering in the last fragments of natural marsh that remained. Its survival carried both wonder and weight. The Hoola painted frog was not simply an amphibian rediscovered by chance. It was a living remnant of deep evolutionary history, a branch of the amphibian tree older than many familiar species that fill modern ecosystems. Its presence in the Hoola Valley added a new layer of meaning to the landscape. This small frog had persisted where almost everything pointed to its disappearance, hiding beneath reeds and mud in places that escaped notice. The rediscovery also served as a quiet reminder of how closely survival is tied to habitat. When the wetlands were drained, the frog had retreated into the last possible corners. When parts of the marshes were restored in later years, it emerged again, drawn back by the return of shallow pools and tangled vegetation. Its story showed that sometimes the most ancient species depend on the most fragile environments, places that require care and patience to maintain. Conservation efforts soon expanded, focusing on protecting the renewed wetlands and searching for additional frog populations. Researchers worked to understand the creature's needs, observing its movements, breeding habits, and relationship with the landscape. Yet even as knowledge grew, the frog remained a quiet presence, emerging mostly at night or during cool hours, as if still cautious from its long years of hiding. The Hoola painted frog's return resonates with more than scientific significance. It carries a softness, a sense of resilience formed over millions of years. It is a creature shaped by ancient rhythms, carrying within its cells the memory of a world that existed long before humans and their maps. Its rediscovery feels like a whisper from deep time, reminding us that even the most fragile threads of life can persist when given the smallest chance. As we leave the wetlands of the Hoola Valley, the image that lingers is gentle. A frog resting among the reeds, its body still and calm, its lineage stretching deep into history. A small life, yet carrying the weight of ages. And as we drift onward in this dreamlike journey, its story becomes part of the long, quiet chorus of species that returned from the brink, adding another soft note to the growing melody of resilience that guides us forward. From the gentle marshes of the Hoola Valley, our journey crosses seas once more. The landscapes below slowly reshape themselves. Arid browns shift to rich greens, wetlands dissolve into forests, and soon the Caribbean comes into view, a patchwork of islands scattered like jewels across blue water. Warm breezes rise, filled with the scent of soil and flowers. Among these islands lies Cuba, long and winding, draped in forests, caves, and mountains that cradle stories older than memory. The island's nights carry a different kind of quiet. Here, the darkness hums with insects and soft rustling beneath the leaves. Vines twist around old trees, forming pathways for creatures that rarely show themselves. This land has sheltered the strange and the ancient for millions of years, offering isolation that protects as much as it hides. And somewhere within its shadows, a small mammal continued its slow survival, unseen by most of the world. The Cuban solenodon is not an animal one expects to find in modern forests. Its appearance seems almost stitched from different eras, with a long, flexible snout, sharp claws, and small eyes that glimmer faintly under moonlight. Its body is covered in coarse fur. When it moves, it does so carefully, placing each step with delicate precision as it searches the forest floor for insects and worms. For much of the 20th century, this creature was believed to have vanished. Habitat loss, predators, and changing landscapes pushed it deeper into hiding. By the late 1970s, researchers feared it had gone the way of many island mammals before it. As years turned to decades without a confirmed sighting, the solenodon slipped quietly into the realm of presumed extinction. But Cuba is a land of hidden corners, full of caves and tangled forests that resist thorough exploration. Remote areas remained untouched by roads or development. In these pockets, life sometimes continued in silence, waiting for the world to rediscover what it once assumed lost. And so, in the year 2003, when a small expedition set out to search for signs of the solenodon, no one knew what they might find. The team walked through dense forests where roots clung to rock like ancient hands. They listened to the soft rustle of the night, moved carefully across uneven ground, and set gentle traps designed not to harm but to reveal. For days, nothing unusual appeared. Then, one night, a trapdoor lifted to reveal a creature with a trembling snout and bright whiskers. Its tiny eyes blinked slowly, its long nose flexed as it sniffed the air. The scientists froze, hardly daring to breathe. There, curling into itself with cautious movements, was the Cuban solenodon, alive after decades of silence. The rediscovery was a moment of gentle wonder. But what made the solenodon extraordinary reached far beyond its disappearance and return. This small mammal possessed a trait so rare in modern mammals that it seemed borrowed from a far older age: venom. The solenodon delivers its venom through grooves in its lower teeth, a method found in some of the earliest mammalian ancestors. When it bites prey, the venom flows along these channels, allowing it to subdue creatures larger than itself. This adaptation connects it to a time when early mammals lived in the shadows of dinosaurs, surviving by night, relying on quiet movement and hidden skills. To scientists, the survival of the solenodon offered more than curiosity. It provided a living link to a branch of evolution that had long faded from the rest of the mammalian world. Most mammals abandoned venom as they evolved new strategies for hunting, defense, and survival. But the solenodon held on to it, carrying forward a feature that once defined a much older age. Studying the solenodon revealed clues about how early mammals behaved, how they hunted, and how they diversified in a world dominated by larger animals. Its bones, muscles, and venom channels told stories about adaptation shaped by ancient pressures. Its DNA became a window into evolutionary paths that most species left behind millions of years earlier. The creature's continued existence also emphasized the importance of island ecosystems in preserving ancient lineages. Cuba's isolated forests acted as a refuge, much like the volcanic canyon that sheltered the Wollemi pine or the rugged cliffs that hid the La Palma giant lizard. Islands create pockets where species can evolve slowly, holding onto traits that disappear elsewhere. This isolation, while fragile, offers a kind of continuity that echoes across geological time. Yet the solenodon's survival remains delicate. Its habitat is limited, and its needs are precise. Conservationists now work to protect the forests where it still moves, keeping invasive predators away and preserving the quiet spaces it depends on. Every sighting brings renewed interest, reminding researchers and locals alike that this creature carries within its small body the memory of a world long gone. As night settles over the Cuban landscape, the solenodon emerges from its burrow. It moves with a soft rustling sound, nose twitching, claws tapping lightly against the earth. It searches patiently, independent and ancient, guided by instincts shaped over tens of millions of years. Its existence is a thread, thin yet unbroken, stretching from a prehistoric past into the present. And as we drift onward from the island's quiet forests, the image of the solenodon lingers like a gentle breath of deep time, a creature small enough to hide beneath leaves, yet carrying within it the vast story of mammalian evolution, a living reminder that even the strangest paths of life can continue, quietly, in places where the modern world rarely looks. Leaving the quiet forests of Cuba behind, our journey crosses the Pacific once more. The ocean stretches wide beneath us, its surface shifting like a great, breathing tapestry. Far ahead, a string of islands appears, scattered across the blue in long, gentle arcs. These islands belong to New Caledonia, a place where ancient lineages have lingered for millions of years, protected by distance, isolation, and the slow rhythms of their own ecosystems. New Caledonia feels different from the other lands we have visited. Its forests are rich with plants found nowhere else, shaped by soils that carry minerals rarely seen in other parts of the world. The air is warm and heavy with the scent of leaves and damp earth. Bird calls echo between the trees, and the ground is soft beneath carpets of moss. It is a place where time seems to move with deep patience, where creatures from long ago still find space to survive. Among the island's quiet residents, one story stands out with a sharp, unexpected edge. It belongs to a lizard, though calling it a lizard hardly captures the presence it carried. Its body grew long and muscular. Its jaws were strong enough to break shell and bone. Its temperament, unlike the gentle posture of many reptiles that inhabit the forests, leaned toward the predatory. Locals who knew of it gave it a name filled with both respect and caution. They called it the terror skink. For many years, this creature existed only in scattered records and old descriptions. A few specimens collected in the early 20th century hinted at its size and strength, but no new sightings came. As years passed, researchers assumed the species had faded into extinction. A predator of this size must leave signs, they thought. Tracks, scattered remains of prey, some trace of its presence, yet the island offered nothing. The forest remained silent, and so the terror skink became another creature placed softly into the past. But islands, as we have come to learn, often conceal what they protect. Their landscapes contain pockets of wilderness where life can continue unseen for decades. Deep ravines, steep cliffs, and dense forests create natural barriers that even determined explorers struggle to cross. In the early years of the 21st century, a group of biologists ventured into one of these remote corners of New Caledonia. They moved carefully over fallen logs and through thick vegetation, listening for the soft movements of reptiles hidden beneath leaves. The forest around them felt ancient, its silence broken only by the occasional rustle or the distant call of a bird. Then, in the dim light beneath a canopy of interwoven branches, they saw it. The creature was larger than any skink they expected to find, its scales dark and glossy, its limbs strong. It lifted its head, revealing sharp, curved teeth that glinted faintly. The terror skink, long thought gone, was alive. It moved with controlled strength, its body flowing across the forest floor like a shadow with weight. Its eyes carried a keen, alert intelligence, the kind held by predators who rely not on speed, but on strategy and patience. The rediscovery sent a gentle ripple through the scientific community. Not loud, not sensational, but deeply intriguing. The terror skink had survived in a part of the island few had explored, feeding on invertebrates and smaller reptiles, living out a life of quiet isolation. Its presence suggested a web of interactions within the forest that humans had barely begun to understand. More surprising still was what the skink's survival hinted about the ecosystem around it. A predator cannot exist alone. It requires stable prey populations, hidden refuges, and an environment capable of supporting a complex food chain. The existence of the terror skink suggested that the remote regions of New Caledonia held an unseen world of activity, a miniature ecosystem shaped by slow, intricate balances. Researchers studying the skink found evidence of this hidden world. They noticed signs of other elusive reptiles, discovered insects known only from fossils, and observed plants that seemed adapted to unique conditions within the forest. It became clear that the terror skink was not an isolated survivor, it was a guardian of a deeper story, a symbol of an ecosystem that had continued quietly beyond the reach of observation. The skink's predatory nature also provided insights into evolutionary paths on isolated islands. Many island reptiles become herbivores or insect specialists due to limited resources. But the terror skink had retained the traits of a hunter. Its strong jaws, sharp teeth, and powerful limbs hinted at an evolutionary pathway that diverged from typical island patterns. Instead of shrinking or softening over time, it maintained a size and strength that allowed it to occupy a high place in the island's food chain. This made it a rare example of an apex reptile on a small island, a role usually filled by birds or mammals elsewhere. Studying its biology helped scientists understand how predators evolve in isolation, how they adapt to limited territories, and how they maintain stable populations over thousands of years. Conservation efforts soon followed, as researchers realized how delicate this ecosystem must be. The terror skink lived in a place vulnerable to invasive species, habitat loss, and climate changes that could alter the island's balance. Protecting it meant protecting the terrain it depended on, the prey it hunted, and the microhabitats that shaped its survival. Today, the terror skink remains rare and elusive. It moves through the forest with the same silent confidence that kept it hidden for so long. Each sighting is precious, recorded with care and respect. It stands as a reminder that Earth still holds wild corners untouched by full understanding, places where ancient cycles continue in shadows and leaf litter. As our journey moves gently onward, the terror skink lingers in memory, a creature shaped by isolation, hardened by time, yet still alive in a world that nearly forgot it. Its story speaks softly of ecosystems that thrive beyond human awareness, waiting patiently for the moment when someone finally looks closely enough to see. From the shadowed forests of New Caledonia, where the terror skink moved with quiet confidence through an ancient world, our journey rises toward a colder sky. The air thins, light brightens, and soon the horizon lifts into the jagged shape of the Himalayas, a mountain range so vast and towering that it seems to hold the sky itself. Here, the world changes with altitude. Forests give way to meadows, then to slopes of cold stone where the wind whispers in long, drawn-out breaths. Snow gathers on distant peaks, untouched and unchanged by centuries of passing seasons. The land feels both immense and intimate, as if every valley shelters its own secrets, folded quietly beneath layers of rock and cloud. Among these mountains lives a creature unlike any other, a small deer with delicate legs, thick fur, and a face shaped by gentle curves. Yet it carries something unexpected. Instead of antlers, two long pointed tusks extend downward from its upper jaw. These tusks, slender and sharp, give the deer an appearance both elegant and strange. Locals once whispered stories about it, sometimes calling it a vampire of the mountains, though it feeds only on leaves and herbs. This was the Kashmir musk deer. The musk deer is named not for its appearance, but for a small gland the males carry, one that produces a scent used to attract mates. For centuries, this scent was sought by traders, perfumers, and collectors, often placing the species at risk. Even so, the deer remained elusive, and many people passed their entire lives without ever seeing one. By the late 20th century, sightings had grown rare. Regional conflicts spread through parts of the Himalayas, pushing people and wildlife into new patterns of movement. Many animals fled higher into the mountains, seeking refuge in steep ravines and isolated slopes where few humans dared to follow. As the noise of conflict grew, the quiet presence of the musk deer faded from records. Decades passed, with no confirmed observations. Conservationists feared the species had disappeared entirely from Kashmir. War zones create many kinds of silence. Some are filled with danger, others are shaped by absence, where people withdraw and leave landscapes empty of human activity. These abandoned places can be dangerous for humans, but sometimes they become accidental sanctuaries for wildlife. Creatures slip into the quiet, moving through shadowed ravines and rocky slopes where no soldiers walk and no roads cut through the terrain. And so it was in this landscape of conflict and isolation that the musk deer continued its life in hiding. It adapted to the harsh terrain with sure-footed steps, navigating cliffs and snowfields with ease. Its pale coat blended with the mountain light. Its movements were soft and soundless, and for years it wandered unseen through places where tension kept people far away. Then, in the year 2014, a team of researchers traveled into a remote area of northeast Afghanistan near the border of Kashmir. The region was rugged and difficult, shaped by steep valleys and cold winds. The team carried hope but little expectation. After all, the musk deer had not been seen for decades. But one morning, as the sun filtered through a thin veil of fog, something moved along the edge of a rocky outcrop. The scientists watched carefully. A small shape emerged from behind a cluster of bushes. A deer stepped into the light. Its body was compact and agile, its ears twitched at faint sounds, and there, glinting slightly in the pale sun, were its tusks. The Kashmir musk deer was alive. The animal stood still for a moment, listening to the wind. Then it moved gracefully along the slope, leaping between rocks, with a confident agility preserved by generations of life in steep terrain. This moment confirmed what had long been whispered but never proven. The species had survived, quietly and independently, shielded by the very conflict that had made the region inaccessible. Rediscovery held layers of meaning. It revealed how easily human absence can create unexpected refuge. War, for all its harm, had inadvertently created pockets of untouched wilderness where endangered species could hide. These spaces, empty of human disturbance, became temporary shelters for life that struggles to compete in more populated regions. For scientists, the musk deer offered new insights into adaptation. Its tusks, once thought to be remnants of primitive ancestors, served as tools for male competition rather than for eating. Its scent gland, prized by humans, played a crucial role in courtship. Its body, perfectly shaped for steep terrain, demonstrated how evolution sculpts creatures to fit the narrowest of ecological niches. Yet the rediscovery also carried a quiet reminder of fragility. Species like the musk deer survive through delicate balances, dependent on landscapes that can shift with even small changes. The return of human activity, the development of new roads, or the spread of predators could quickly erase the refuge the deer had found. Today, conservationists work to protect the habitat of the musk deer while acknowledging the difficulties of studying wildlife in regions marked by conflict. Each sighting is precious, a testament to endurance shaped by isolation. The musk deer remains one of the most elusive mammals in the world, moving through shadows with a grace that belongs entirely to the mountains it calls home. As we continue our journey, the image of the deer lingers softly. A small figure poised on a cold slope, tusks catching the morning light, its breath rising in thin white clouds. A creature that survived not by strength, but by quiet persistence in a landscape shaped by both nature and history. From the cold Himalayan air, our path turns southward toward a warmer world. The mountains soften into rolling green, then into deep tropical forests layered with fog. We drift over rivers that sparkle beneath sunlight, filtered through thousands of leaves. Soon we reach an island of vast mystery, one of the most rugged and least explored landscapes on Earth. This is New Guinea, a place shaped by steep ridges, dense jungles, and valleys so remote that entire ecosystems remain hidden from human knowledge. The sounds of this island are unlike anywhere else. Insects hum in shimmering waves, birds call with bright, flute-like notes, and beneath this tapestry of forest noise, there is a very different sound, one that once echoed across the mountains, like a thread woven between earth and sky. It is a sound both haunting and beautiful, a call that rises in long, pure tones, then shifts into sudden harmonic leaps. This was the voice of the New Guinea singing dog. For centuries, the singing dog lived high in the island's cloud forests, rarely seen by people. It had lean limbs suited for climbing steep slopes, golden fur that blended with the moss and soil, and eyes that held the alert intelligence of a creature shaped by isolation. Its most distinctive feature was its voice. When the dogs sang, they did not bark like their distant cousins. Instead, they produced long notes that wavered and overlapped, almost like a choir of flutes drifting through the mountains. But by the mid-20th century, sightings of wild singing dogs vanished. Logging roads spread into some of the valleys, and domestic dogs introduced by local settlements interbred with whatever wild dogs remained. The forests were vast, but the true wilderness shrank. Decade after decade passed without a confirmed encounter. Wildlife researchers assumed the species had quietly disappeared from the wild. A few individuals survived in captivity, preserved in sanctuaries, but the wild lineage was believed lost forever. It was a quiet kind of extinction, one marked less by a final event and more by an absence of evidence, an echo that slowly faded until it seemed certain it would not return. Yet New Guinea is a place where the land hides its secrets well. The island contains some of the most inaccessible terrain on Earth, carved by steep ravines and shrouded by rain clouds that cling to the peaks. Entire regions remain untouched, difficult to reach even with modern tools. In these hidden pockets of wilderness, creatures continue their ancient rhythms, unseen by the world beyond. And so, in the early 21st century, a few blurry photographs surfaced from the highlands. Local communities spoke quietly of wild dogs moving through distant valleys, climbing cliffs with surprising ease. Their descriptions matched what had once been known about the singing dog, but scientists needed more than stories. They needed proof strong enough to stand against decades of uncertainty. That proof finally emerged around 2016 when a group of researchers led an expedition into one of the most remote regions of New Guinea. They traveled through thick jungle and climbed steep ridges, carrying equipment intended to record sounds and collect genetic material. Their goal was simple but daunting: to determine whether the singing dog had truly survived. Deep within the mountain valleys, camera traps captured something remarkable. Images of lean, golden dogs moving through the forest appeared on the screens. Their faces, their builds, their postures all matched the few captive singing dogs known to exist. But the clearest confirmation came later, when genetic samples from these wild dogs were analyzed and compared to those in captivity. The results were quietly astonishing. The wild Highland dogs were not simply relatives, they were the same lineage, nearly identical, carrying the ancestral genes that once gave rise to every domestic dog on Earth. Modern dogs, from tiny companions to large working breeds, trace their origins back through many branches of evolution. But the singing dog represented one of the deepest splits in that family tree, a living echo of the earliest canines that formed relationships with humans tens of thousands of years ago. This rediscovery did more than confirm the survival of a species. It opened a window into the origins of domestication itself. The singing dog's DNA preserved ancient patterns almost unchanged by the selective breeding that shaped modern dogs. By studying these animals, scientists gained insight into how early dogs looked, behaved, and communicated. The singing dog was not just a lost species, it was a living archive of canine history, carrying within its genes the quiet memory of the deep past. But perhaps the most striking part of the singing dog's survival is its voice. In the wild, the harmonic call rises through the mountain air like a sound from another world. It flows in long, clear tones that shift into layered chords, as if multiple notes are produced at once. These songs carry far across the ridges, drifting through clouds and echoing off stone. For researchers who heard recordings of these wild calls, it felt as though the mountains themselves had awakened an ancient instrument. The rediscovery also demonstrated how war, isolation, and rugged geography can shield wildlife from human disturbance. The highlands of New Guinea, shaped by valleys rarely visited and cliffs difficult to climb, became an accidental refuge for a lineage thought gone. Without roads or settlements, the singing dog remained hidden in landscapes where time slows and the forest speaks in its own language. Today, efforts are underway to protect this remarkable species. Conservationists aim to preserve the valleys where they still roam, while studying their behavior and genetics to strengthen captive populations. Each image of a wild singing dog, each new call recorded, becomes a gentle reminder that the world still holds mysteries, waiting patiently in remote places. As we drift onward in our quiet exploration, the sound that lingers is soft and haunting, a long note rising through mist, a harmony echoing through a valley older than memory. The voice of a lost lineage, alive once more in the mountains where it first learned to sing. From the misty mountains of New Guinea, where the singing dog carried its ancient harmonies into the clouds, our journey shifts gently westward. The air warms once more, the forests thin, and the ocean appears beneath us like a calm mirror stretching toward the horizon. Scattered across its surface lie small islands, some little more than rings of white sand and green foliage, others formed from coral lifted slowly by the sea's steady pulse. Among these islands sits one of the most unusual places on Earth, a shallow atoll shaped like a broken oval and fringed by turquoise water. This is Aldabra. Aldabra belongs to the Seychelles, yet it feels older than any single nation, older even than many continents. Its limestone surface rises only a few meters above the sea, shaped by tides and wind and time itself. Giant tortoises roam its open spaces like slow, living stones. Mangroves twist their roots into the shallow waters, creating miniature forests filled with crabs and fish. Birds wheel overhead, the air carrying the scent of salt and sun-warmed rock. The atoll has been isolated for hundreds of thousands of years, rarely visited and rarely disturbed. In such a place, evolution moves in its own direction, creating creatures found nowhere else. One of these creatures was a small bird that lost the ability to fly, choosing instead to walk among the shrubs and limestone flats. Its wings shrank, its legs grew strong, its feathers thickened to shield it from sun and wind. This was the Aldabra rail. The story of this rail, however, is unlike the tale of any other creature we have met. It is a story not of rediscovery, but of reemergence. Its extinction was real, its disappearance was complete, and yet, somehow, it returned. To understand this strange journey, we drift backward in time to an age when sea levels rose and fell in long, slow cycles. During one such rise, tens of thousands of years ago, much of Aldabra sank beneath the ocean. The land vanished. Its unique species vanished with it. The first Aldabra rail was among them, a flightless bird unable to escape the rising water. Its bones remained buried in limestone layers, silent evidence of a life that ended with the drowning of an island. For most species, this is where the story would stop. Extinction, as we have seen across our journey, is often final. It closes doors, quiets landscapes, and turns living rhythms into memories preserved in stone. But when the sea levels later fell, Aldabra rose again from the water. The sun warmed its stone once more, plants colonized the new surface, insects returned, tortoises wandered out of the surf. Birds from nearby islands flew across the water in search of new habitats. Among them were white-throated rails from Madagascar, small and capable of flight, their wings bringing them to a place that had been empty for millennia. On this renewed landscape, free from predators and thick forests, these birds began to change. Flight was no longer necessary. Food lay on the ground. Safety came from speed and awareness, not from wings. Over generations, their wings grew smaller, their bodies grew stronger, and slowly, through a process shaped by environment and time, a new flightless rail emerged. It matched the bones of the earlier rail almost exactly, as if the island had written the same story a second time. This extraordinary event revealed something profound about the nature of evolution. Life, when placed in the same conditions and given the same pressures, can shape itself into the same form more than once. The Aldabra rail did not survive extinction. It reinvented itself through a lineage that recognized opportunity and followed the same path its ancestors once walked. Scientists call this phenomenon iterative evolution, a rare natural experiment where evolution repeats an earlier outcome, creating a creature nearly identical to one that disappeared long ago. The fossil record of Aldabra shows two rails separated by thousands of years, each with the same adaptations, each with the same flightlessness, each shaped by the same island. It is as if the atoll remembered what kind of bird fit best within its quiet boundaries. This repetition is not a simple miracle of chance. It speaks to the powerful relationship between environment and life. Aldabra, with its harsh limestone terrain, lack of predators, and open spaces, naturally selects for birds that walk rather than fly. Wings become unnecessary, strong legs become essential. Over time, evolution gently carves the same shape from the raw material of a different lineage. When researchers first recognized that the modern Aldabra rail was not a surviving descendant of the ancient one, but a new species molded in the same image, a sense of wonder settled across the scientific world. It was a reminder that extinction does not always mean an end to possibility. Sometimes, under the right conditions, life writes the same chapter twice. Today, the Aldabra rail thrives. On the atoll's limestone ground, it darts among shrubs in search of insects. It moves with a confidence shaped by generations of adapting to a predator-free world. Its presence is not simply a story of survival, but of return, of repetition, of nature recreating a form that had once vanished beneath rising seas. As we drift gently away from Aldabra's sunlit stone, the rail's quiet footsteps linger in the imagination, a reminder that evolution is not only creative, but sometimes cyclical, capable of revisiting its own past and bringing it softly into the present. From the warm limestone shores of Aldabra, where a small rail rewrote its own past through the quiet force of evolution, our journey rises once again across the water. The ocean unfolds beneath us like a boundless sheet of blue silk, shifting gently with the rhythm of wind and tides. As we drift across its surface, the world ahead becomes softer, then sharper, and finally resolves into a scattering of islands in the western Atlantic. These islands are small, fragile, and surrounded by restless waves, yet within their modest boundaries, a story of astonishing resilience once unfolded. This is the story of the Bermuda petrel. Centuries ago, when early sailors first reached Bermuda, they described the nights as filled with strange, ghostly cries that echoed across the sea. These calls belonged to a bird that only visited land to nest deep within burrows, carved into soft earth or hidden cracks among the rocks. The petrel was gentle, graceful in flight, and profoundly connected to the general Atlantic winds that carried it across vast distances, but human arrival changed everything. The soft soils where petrels nested were trampled underfoot. Rats, cats, and pigs introduced by ships quickly spread across the islands. Forests were cut. Fires swept through the underbrush. Within only a few generations, the Bermuda petrel, unable to defend itself from these sudden pressures, seemed to vanish. By the 1600s, the bird was declared extinct. Its eerie calls disappeared, its nesting grounds grew silent, and the world moved on. For centuries, the story of the petrel lived only in old sailors' journals and in the bones unearthed by naturalists who searched the island's past. The bird was remembered as a symbol of the fragility of island life, a reminder of how quickly human presence can reshape delicate ecosystems. No one truly expected it to return. Yet the ocean has its hidden corners, and small islands sometimes guard their secrets with fierce determination. In the mid-20th century, the Bermuda archipelago had long been studied, mapped, and developed. Still, a few islets remained untouched, their jagged cliffs rising defiantly from the sea. These rocks were battered by wind and waves, far too dangerous for settlement and too remote for casual visitors. Over centuries, storms had carved deep cracks and crevices into their limestone. The cliffs stood like forgotten fortresses, shaped by the force of the Atlantic. In 1951, a small group of scientists and conservationists visited these rugged islets to study local wildlife. The journey across the water was difficult. Waves struck the boat with rhythmic force. Mist gathered on the spray. Upon reaching the rocky shore, the team climbed carefully along narrow ledges, their movements slow and deliberate. As they explored a sheltered cliff face, they noticed something almost impossible. A small burrow, tucked between two slabs of ancient stone, held a fragile nest, and within that nest sat a bird with soft gray plumage, dark eyes, and long, slender wings. It looked out at the researchers with calm curiosity, unaware that its existence contradicted centuries of belief. The Bermuda petrel, thought extinct for more than 300 years, was alive. The discovery moved gently through the scientific world like a warm tide, not loud or triumphant, but full of quiet wonder. The petrel had survived in the narrowest of places, using the inhospitable nature of the islets as protection. Their cliffs, sharp and windswept, were too dangerous for predators. The birds had retreated into the last corners that remained untouched. Only a handful of nesting pairs were found. Their numbers were heartbreakingly small, but those few survivors became the foundation of one of the most inspiring conservation efforts of the modern era. Scientists and local authorities began working together with care and urgency. They protected the nesting sites by limiting access to the islets. They removed invasive predators from nearby areas. They created artificial burrows to guide the fledglings to safe places. Later, they established a program to translocate chicks to restored habitats on larger islands. Each step was taken slowly, patiently, always with the long-term survival of the species in mind. The work was difficult and sometimes uncertain. Storms threatened nesting grounds, the bird's own life cycle, tied tightly to the rhythms of the ocean, made growth slow. Yet year after year, the population began to rise. From only a few pairs in the 1950s, the petrel's numbers grew gradually, reaching more individuals than had existed since the time before its presumed extinction. The Bermuda petrel's return is not just a rediscovery, it is a testament to what sustained, thoughtful conservation can achieve. Unlike many Lazarus species that survived unnoticed, protected only by chance or isolation, the petrel was brought back by hands and hearts working together. Its survival became a symbol of hope, a reminder that even when a species seems lost, dedicated care can help it find its way home. Today, the Bermuda petrel continues to glide across the Atlantic, its wings catching the light of sunrise and moonrise alike. It still nests in hidden crevices, its calls drifting over the waves like a soft echo of the past finally restored. Its presence enriches the islands once again, adding a new layer of life to cliffs shaped by wind and time. As we leave the storm-battered islets behind, the petrel's quiet resilience lingers with us, a bird that would not vanish, even when the world assumed it already had, a reminder that life, when given even the smallest refuge, can find a way to endure across centuries. From the storm-shaped cliffs of Bermuda, where a small seabird reclaimed its place in the world after centuries of silence, our journey turns once more toward distant continents. The ocean thins, the air cools, and soon the soft blues of the horizon sharpen into the outline of another vast landmass. Australia rises beneath us, ancient and rugged, carved by wind, time, and the slow drift of continents long separated from the rest of the world. Much of Australia is warm and dry, but far to the southeast, where the terrain climbs into jagged peaks and rolling alpine ridges, a different world emerges. The air becomes crisp, snow gathers along the slopes during winter, clinging to the rocks and filling the valleys with a soft white silence. In summer, the meltwater trickles into streams that weave through fields of alpine grass. It is a landscape shaped by extremes, where cold and warmth trade places in long, seasonal rhythms. For many years, these mountains were known more for their stillness than their secrets, yet beneath their rocks and snow lay a creature that carried the quiet memory of another age. Scientists first learned of it from fossils discovered deep within caves. These fossils were tiny, belonging to a small marsupial with delicate bones and a compact form. The creature had lived tens of thousands of years ago, during a time when the Australian landscape was colder, when glaciers touched the peaks and the high country more closely resembled the frozen lands of the distant north. The tiny mammal was called the mountain pygmy possum, and based on the fossil record, it had long vanished, another creature swept away as the world warmed and the ice age ended. Generations of researchers spoke of it as a reminder of ancient Australia, a species preserved only in stone. Then came the year 1966. A group of scientists exploring the high country near Mount Hotham in Victoria set small traps While studying local wildlife, they expected to find typical alpine rodents. But one morning, when they checked the traps, they found a creature that did not match anything known from modern Australia. It was small enough to rest in a cupped hand. Its fur was soft, gray-brown, and its tail curled like a delicate spiral. It blinked up at them with bright eyes, its whiskers trembling with curiosity. The researchers looked again, stunned. The creature in their hands was not a rodent. It was a living mountain pygmy possum, a mammal that had been known only from fossils, tens of thousands of years old, was alive, breathing gently, its tiny paws curled beneath its body. The scientists quickly realized that this was not a species returned from extinction in the usual sense. It had never disappeared entirely. It had simply lived in hiding, tucked into the cold corners of the alpine range where few people ever looked. With this rediscovery came a deeper understanding of how the possum had survived. Its life was shaped by hibernation, a strategy that allowed it to endure the harsh winters of the high mountains. During the coldest months, the possum curled into rock shelters, slowing its heartbeat, lowering its body temperature, and entering a deep, energy-conserving sleep. Snow piled above the rocks, insulating the possums beneath. The cold became a kind of shelter, protecting them precisely because it kept other predators away. This hibernation pattern echoed the conditions of the Ice Age, reflecting strategies that had developed long before humans walked the Australian continent. The possum was not merely a survivor, it was a living blueprint of ancient adaptation. Its body remembered how to endure winters far colder than modern Australia ever experiences. In this way, the possum became a small ambassador from a distant climatic era, carrying forward biological knowledge that had faded from most of the natural world. Researchers soon discovered that the possums relied on specific foods to survive their active months. One of these foods was the bogong moth, a migratory insect that traveled vast distances each year, gathering in the alpine region during summer. The possums fed on these moths for energy before returning to their winter dens. It was a delicate partnership between mountain and sky, one that had persisted since long before the continents reached their current shapes. As scientists learned more, they realized how fragile the possum's existence had become. Its habitat spread across only a few alpine regions in Victoria and New South Wales. Roads, ski resorts, and warming temperatures threatened the stability of its environment. Conservationists stepped forward with care and determination, protecting rock shelters, guiding populations across isolated landscapes, and searching for new possum colonies hidden in unexplored patches of the high country. Slowly, the story shifted from rediscovery to protection. Each sighting of a possum became a quiet celebration. Each new den uncovered in the Wan Mountains brought hope that the species could continue to carry its ancient lineage into the future. Today, the mountain pygmy possum remains one of the most remarkable examples of how life can wait in silence, preserved by conditions that resemble the distant past. It curls into its winter sleep just as it did during the Ice Age, its small body warmed by the memory of ancient adaptations. And when spring comes, it wakes again, moving softly through a world that nearly forgot it existed. As we drift onward from Australia's alpine ridges, the image that stays with us is gentle and enduring. A tiny creature curled beneath rocks, waiting patiently through winter. A survivor of ages, opening its eyes once the cold lifts, stepping back into the light with the unbroken continuity of life shaped by time itself. From the cold Australian peaks where a tiny possum survived in the quiet rhythm of its ancient hibernation, our path drifts northwest across deserts, seas, and the warm winds that rise along the Horn of Africa. As we travel, the landscape below unfolds into shades of gold and rust, broken by pockets of green, where acacia trees lift their thorny branches toward the sun. This is Somalia, a land of rugged plateaus, rocky outcrops, and dry riverbeds shaped by seasons that come and go with the softness of passing time. Here, life survives by endurance more than abundance. Small mammals dart through shadows, birds circle silently in the heat, plants anchor themselves in soil hardened by the sun, their roots reaching deep for every drop of water. It is a landscape that teaches patience, where creatures evolve finely tuned strategies to navigate scarcity. For many years, one of these creatures seemed to disappear entirely. The Somali elephant shrew, also known as the Somali sengi, had been described in the 1970s from only a few specimens. The animal itself was small, with soft brown fur, slender legs, and a long, flexible nose shaped like a tiny elephant's trunk. It moved with astonishing speed, darting across dry ground in quick, precise bursts. But after its initial discovery, it was not seen again. Decade after decade passed. Researchers searched across the region but found no trace. Without new sightings, the species slipped into the uncertain category of missing, suspended somewhere between survival and disappearance. Some feared it had faded into extinction, quietly lost in a landscape where even footprints vanish quickly under wind and heat. Yet while the scientific world waited, the people who lived among these landscapes carried their own knowledge. To many in local communities, the elephant shrew was not a mystery or a memory. It was simply part of the world they knew, a creature so familiar that it hardly seemed extraordinary. They saw it, darting near rocks, disappearing into shrubs, or using its long nose to search for insects beneath leaves. While its absence puzzled researchers far away, its presence remained alive in the stories and observations of the people who walked the land every day. This difference between scientific records and local memory would become the key to one of the most heartwarming rediscoveries in recent years. In 2020, a team of researchers set out to search for the sengi with renewed hope. They traveled with local guides who knew the rhythms of the land intimately. These guides recognized certain habitats as natural homes for the shy creature, directing the team toward rocky slopes, dry thickets, and places where insects gathered beneath fallen debris. The researchers set baited traps designed to gently capture small mammals without harm. The traps were simple wooden boxes placed at strategic spots suggested by the local guides. The team waited through the heat of the day, listened to the wind move across the stones, and watched shadows lengthen across the earth. And then, almost quietly, the past stepped into the present. When the researchers opened one of the traps, they found a small, delicate creature curled inside. It had bright eyes and a long nose that twitched in quick, curious movements. Its legs were thin and powerful, built for sudden sprints. It looked up with an expression faintly puzzled, as if wondering how it had become the center of such attention. The Somali elephant shrew, missing for half a century, was alive. The team handled the animal with great care, observing it briefly before releasing it back into the wild. Over the following days, they captured and released several more individuals, confirming that the species had been living quietly all along in parts of the Horn of Africa. It had not disappeared. It had simply existed beyond the narrow reach of science, protected by the vastness of the land and the knowledge of people who never forgot it. This rediscovery held a deeper significance than scientific surprise. It became a powerful example of what can happen when researchers work closely with indigenous communities. For years, scientific surveys had missed the animal entirely, often because they searched in the wrong places or at the wrong times. Local guides, however, understood the subtle signs of the sengi's presence, from the tiny pathways it carved into the dust to the sounds it made while foraging. Collaboration bridged two kinds of wisdom. Scientific knowledge brought tools for confirmation and study. Indigenous knowledge brought insight shaped by generations of living with the land. Together, they revealed a truth that neither could have uncovered alone. As scientists studied the elephant shrew more closely, they found that it belonged to a lineage that included some of Africa's most ancient small mammals. Despite its name, the senji is not closely related to shrews. Instead, its evolutionary ties stretch toward elephants, manatees, and aardvarks, forming a branch of the mammal family tree that diverged long ago. To see it alive was to glimpse a connection to a deep and distant past. Today, the Somali elephant shrew remains elusive but not lost. Conservationists work to understand its habitat needs, while local communities continue to guide researchers and share observations. It scurries across dry stones with the same quick grace it always had, its tiny trunk sweeping across the ground as it searches for insects beneath the heat of an African sun. As our journey drifts gently away from the Horn of Africa, the image that lingers is soft and lively. A small creature darting between rocks, unseen by most, yet known deeply by those who share its home. A reminder that the living world is not only shaped by scientific discovery, but also by the quiet, steadfast knowledge held within the hearts of people who walk the land each day. From the warm plateaus of the Horn of Africa, where the tiny elephant shrew reappeared through the shared knowledge of local guides and scientists, our journey drifts eastward across the Indian Ocean. The water below shimmers in shades of deep blue and glassy green, interrupted only by slow-moving currents and the occasional shape of an island rising from the waves. As we move closer to the equator, the world grows thicker with heat. Clouds gather like soft white towers, and forests spread beneath them in great dark carpets, rich with layers of life. Soon we reach the islands of Indonesia, a region where the air feels almost alive with movement. Insects hum through the understory, birds flash between branches, leaves glisten after sudden rain showers. These forests are among the most biodiverse places on Earth, shaped by volcanic soil and centuries of monsoon rhythms. They hold creatures known only to locals, known only to stories, or known only to the silence of their hidden lives. High in these canopies once lived an animal so extraordinary that its existence seemed almost mythical. It was a bee, but not the small, delicate kind that visits backyard flowers. This was a giant, a creature with a body the length of a human thumb and wings broad enough to recall a hummingbird's quick shimmer. Its jaws were powerful, shaped like curved pincers that could cut through wood. Its name was Wallace's giant bee, honoring the naturalist Alfred Russel Wallace, who first described it in the late 1800s. After Wallace's time, the bee faded from scientific records. Few people ever saw it again. Expeditions searched, but the forests changed, and the bee seemed to vanish into the folds of time. For nearly a century, it remained missing. Many assumed it had quietly slipped into extinction, like so many species lost when forests are cut or fragmented. Yet there were still whispers from local communities, suggesting that in remote corners of the islands, something large and buzzing still lived within hollowed trees. In the year 2019, a small team of researchers and photographers traveled deep into the Indonesian archipelago with a simple yet unlikely goal: to find a creature that had not been confirmed alive for almost 100 years. Their search took them through thick forests where vines hung like curtains and the air was warm and heavy with humidity. They walked carefully through tangled undergrowth, crossed streams shaped by rainfall, and listened to the constant chorus of insects that lived unseen above and around them. The bee, if it still lived, was known to nest inside the hollows of trees made by termites. So the team focused their search on decaying trunks and rotting branches, places where wood softened from years of rain and heat. Day after day, They inspected tree cavities, peering into dark spaces filled with dust and old fibers. Then, on a quiet afternoon, one of the researchers paused beside a large fallen tree. Something about the cavity inside caught their attention. It was lined with a material that glimmered faintly in the shifting light. They leaned closer, lifting a small flashlight to illuminate the interior. And there, clinging to the wall of the hollow, was a massive bee. Its wings were folded neatly along its sides. Its body was dark and shining, covered in tiny hairs. Its large, curved mandibles glinted sharply. For a moment, the forest seemed to hold its breath as the bee turned its head slightly, revealing a presence that felt both ancient and powerful. Wallace's giant bee, missing for nearly a century, was alive. The sight of it carried a quiet weight. This was not simply a rediscovery, it was a reminder that the world still holds wonders large enough to surprise us, even in an era filled with satellites, maps, and endless data. The bee had lived through decades of deforestation, storms, and changes in the forest structure, remaining hidden in remote pockets where few people traveled. It was a creature of endurance, its life carried in the quiet balance between tree, termite, and forest. As scientists observed it, they noticed how the bee used its powerful jaws to gather resin from nearby trees, shaping it into a protective layer for its nest. This behavior, ancient and efficient, had allowed the species to survive through the shifting landscapes of island ecosystems. The bee's size, once thought an evolutionary oddity, became a symbol of resilience in a world where many large insects are threatened by habitat loss. The rediscovery also highlighted something deeper about biodiversity. The bee had not survived in an untouched paradise. It had lived within forests that humans often walked past, forests close to villages, forests that appeared ordinary on maps. It had hidden in plain sight, above eye level and beyond expectation, waiting for the rare moment when someone would look closely enough to see. This realization softened the boundary between the familiar and the unknown. It suggested that many more species, large and small, might still dwell in these forests, living quiet lives on branches that rarely meet human eyes. The giant bee's return was a reminder that extinction is sometimes only an assumption made in the absence of seeing, and that the world's wildest stories can begin again with a single glimpse through the hollow of a fallen tree. As we drift onward from the Indonesian canopy, the shape that lingers in memory is both gentle and humbling. A great bee resting in the dim interior of a wooden chamber, its wings folded, its life unfolding in rhythms older than the maps that nearly erased it. A reminder that the living world still hums with mysteries, each one waiting patiently beneath the shade of leaves. From the humid forests of Indonesia, where a giant bee hid in the dim hollows of fallen wood, our journey glides westward across the Indian Ocean. The water below gleams in shifting shades of blue, calm at times, restless at others, shaped by winds that carry the scents of faraway lands. Eventually, an island rises on the horizon. Its outline is irregular, its forests dense, its landscapes full of mysteries shaped by millions of years of isolation. This is Madagascar, a place where evolution has followed its own winding paths, creating life found nowhere else on Earth. Madagascar's forests are thick and layered, filled with the calls of lemurs at dawn and the flutter of insects beneath broad leaves. Ferns grow in spirals along the forest floor. Ribbons of sunlight thread through canopies woven from vines and branches. The air is warm and heavy, carrying the smell of damp soil and moss that clings to ancient tree trunks. It is here, in this world of shadows and green light, that the Malagasy serpent eagle once made its home. For centuries, this eagle was known as one of Madagascar's most elusive raptors. It was neither large nor small, but slender, with long legs that allowed it to move gracefully through branches. Its feathers were mottled in patterns that blended with the forest's shifting shadows. Its eyes were sharp, dark, and patient, and its diet, unusual for an eagle, often included snakes and lizards, creatures that twisted through the underbrush or rested on warm stones. But by the 1930s, the serpent eagle seemed to fade from the island. Madagascar's forests were shrinking, agricultural fields expanded, logging increased, and as the trees fell, so did the habitats of countless species. Sightings of the eagle disappeared entirely. Decades passed without a single confirmed report. Many scientists began to believe the bird had slipped quietly into extinction, another loss in a world where forests dwindled too quickly for life to adjust. Still, in a land as layered and complex as Madagascar, silence does not always mean absence. In the early 1990s, conservationists began working with local communities to restore forests that had been degraded over time. Saplings were planted, hillsides were protected. Gradually, in certain regions, the forest returned. Trees grew taller, understory plants flourished, birds began to return to branches that had been empty for years, and it was within this slow, patient return of green that something unexpected appeared. In 1993, a team of researchers journeyed into a restored forest region in the northeast of the island. Their work focused on studying lemurs and tracking the recovery of tree species. The forest around them was still young, but alive with movement. The researchers often paused to listen to the rustling of leaves, the distant calls of animals that had begun to reclaim the land. One afternoon, as the light slanted through the trees and softened the edges of the forest, a shadow passed overhead. It moved with a quiet but unmistakable grace. The researchers looked up, expecting perhaps a hawk or a familiar local bird. Instead, through a gap in the canopy, they saw a shape they did not immediately recognize. The bird perched on a high branch, still and alert. Its plumage blended with the bark. Its long legs gripped the wood with steady strength. Its head turned slowly, revealing sharp features and eyes that reflected both caution and confidence. When it spread its wings and took flight again, the pattern of its feathers matched the old field notes of a species considered gone. The Malagasy serpent eagle had returned to sight. The rediscovery brought a quiet sense of awe. This was not a species that had survived on its own in untouched wilderness. It had survived because new forests had grown, because saplings planted decades earlier had become strong enough to support life, because the island, with human help, had begun to heal. The serpent eagle's reappearance became a symbol of possibility. Conservationists often speak of trees as the backbone of biodiversity, but the eagle reminded them that reforestation does more than restore plants. It restores worlds. It brings back the hidden relationships that forests hold, from insects in the soil to predators in the canopy. The return of the serpent eagle suggested that even species thought lost might return if their homes slowly re-emerged. As researchers studied the eagle, they learned more about its quiet resilience. The bird preferred dense, tall forests where it could move with ease among branches. It hunted in shadows, relying on vision honed over centuries of life in a place where reptiles and small mammals formed a rich part of its ecosystem. And though it remained rare and cautious, its presence offered hope that other species, even those presumed extinct, might still linger in the folds of Madagascar's forests. Local communities played a crucial role in protecting these habitats. Their stewardship ensured that trees were not cut prematurely, that saplings had time to grow, and that forest corridors remained intact. Their knowledge of the land, passed down through generations, helped scientists understand where wildlife might reappear and how the landscape could support them. Today, the Malagasy serpent eagle remains one of the island's rarest raptors. It glides through the canopies with a soft, deliberate rhythm, often unnoticed by those passing below. Its survival is delicate, tied closely to the protection of Madagascar's remaining forests. Yet its rediscovery stands as a gentle reminder that even fragile species can return when given space, time, and care. As we drift onward from Madagascar's renewed green, the image that lingers is of a slender eagle perched high in the canopy, its feathers blending with the bark, its presence quiet but powerful, a shadow that once vanished, now returned through the slow regrowth of trees, a reminder that when forests heal, they bring more than leaves back to the world. They bring life. From the canopies of Madagascar, where a hidden eagle glided back into the world through the slow return of trees, our journey crosses the wide Pacific. Hours pass in the quiet drift above open water. The sea beneath us stretches without end, a vast blue cradle, holding stories of migration, isolation, and change. Eventually, dark shapes rise from the horizon, each one carved by fire and tempered by waves. These are the Galapagos Islands, a living museum of evolution where time seems to move at its own slow rhythm. The islands are scattered like stepping stones across the equator. Some are lush and green, filled with mangroves and birdsong. Others are stark, shaped by black lava fields that still hold the imprint of ancient flows. One of the tallest of these islands is Isabella, crowned by Wolf Volcano, a place where clouds gather near the summit and winds carry the scent of ash and salt. Wolf Volcano rises in long slopes of gray and rust-colored rock. Its surface is dry and harsh, shaped by eruptions that happened long before any humans set foot here. The air is thin near the top. The sun feels sharper, burning against the stone. Few plants grow this high, and fewer animals call this place home, yet hidden within the cracks of the volcano, a secret waited for millions of years. For most of the 20th century, scientists believed that the land iguanas of the Galapagos belonged to only a few known species. These iguanas were hardy and strong, with thick legs and bodies built for life under a bright equatorial sun. They lived on lower slopes and coastal regions, feeding on prickly pear pads and wandering across sandy plains. Their colors blended with the earth, offering camouflage in a land shaped by predators in other ages. But in 2009, during a survey near the remote northern slopes of Wolf Volcano, researchers noticed something strange. They saw a shape moving across the dark ground. It looked like an iguana, but its color was unlike anything recorded before. Instead of dusty yellows or browns, this animal carried patches of soft pink across its skin, as if the color of volcanic dawn had settled into its scales. The sight was unexpected. The iguana moved slowly but deliberately, its claws gripping the rough stone. Its body was large and muscular, with a face shaped by deep time. Under the sunlight, the pink hues shimmered faintly, not bright like a flower, but muted like the inside of a seashell. The researchers watched with quiet amazement. This was no familiar species. It was something different, something older. More individuals appeared as the team continued exploring the high slopes. Each one wore the same pale pink markings, combined with patterns of darker bands. Their behavior differed too. They lived at higher elevations than other land iguanas, in a place where the ground was rough, food was sparse, and the air was thin. They seemed adapted to a world of stone and silence, far from the coastal regions where their relatives moved. The discovery had to be confirmed with careful study. Over the following months, scientists collected samples from the pink iguanas and compared them with genetic material from other Galapagos species. The results revealed something extraordinary. The pink land iguana was not a variety of an existing species. It belonged to a lineage that had split from other iguanas several million years ago. It had evolved on its own, shaped by the isolation of Wolf Volcano following a path that no other iguana had taken. This meant that the pink land iguana represented an evolutionary experiment that had unfolded quietly in the shadows of the volcano. While other species adapted to coastal shrubs and sandy plains, this iguana had adapted to bare rock, sparse vegetation, and the unique pressures of its high altitude home. It was a reminder that evolution does not move with intention, but with opportunity. It responds to isolation, competition, and chance, creating forms of life that seem almost unimaginable until we see them ourselves. The pink iguana's survival is fragile. Its entire population lives on a single volcano. The slopes are steep, prone to erosion, and vulnerable to weather shifts. Predators introduced by humans, such as feral cats and rats, pose threats to eggs and young iguanas. Scientists now work carefully to monitor and protect the species, knowing that its loss would mean the end of a lineage millions of years in the making. Yet its presence tells a story far larger than its size or rarity. The iguana stands as a symbol of Earth's hidden evolutionary experiments, the quiet branches of the tree of life that grow in places few people visit. It shows how isolation can create wonders, how landscapes shaped by fire can give rise to forms of life that seem almost impossible, and how many species remain unknown simply because no one has yet climbed the slopes where they live. As we drift away from Wolf Volcano, the image that lingers is gentle and surprising. A pale pink creature resting on black volcanic stone, its body warmed by the same sun that painted its skin. A reminder that even in the most remote corners of the world, evolution continues to shape stories that wait patiently for discovery. From the volcanic slopes of the Galapagos, where a pale pink iguana carried the secrets of ancient evolution in its scales, our path drifts back toward the great continents. The Pacific spreads below like a vast sheet of shifting silver, reflecting clouds that drift as softly as thoughts. As we move inland across North America, the landscape changes again. Forests thin, mountains roll into wide plains, and the grasslands open beneath us like an endless sea of quiet motion. Here, the wind runs low across the earth, grasses sway in long waves that catch the sun. Prairie dogs stand upright beside their burrows, chirping sharply before diving underground. Hawks circle high above, their shadows sliding across the ground like drifting leaves. It is a world shaped by open space, by sky, and by the delicate balance of predator and prey. Within this world once lived an animal so slender and swift that it moved almost like a ribbon of pale golden fur. The black-footed ferret, with its mask of dark markings and long flexible body, was a specialized hunter of the prairie dog towns that covered the plains. It slipped through burrows with ease. It relied on the prairie dogs not only for food, but for shelter in the maze of tunnels beneath the earth. For a long time, the ferret thrived quietly, unseen by most people. But as the 20th century unfolded, the prairies changed. Prairie dog populations fell as land was converted for agriculture and development. Poisoning campaigns targeted the rodents, and with them, the homes of the ferrets disappeared. Diseases spread rapidly. By the 1970s, no ferrets had been reliably seen for years. Biologists began to accept that the species was gone. In 1979, the black-footed ferret was officially declared extinct. It was a quiet announcement, one among many, during an age when wildlife declines were accelerating. Yet even in extinction, the story was not finished. 2 years later, in 1981, something unexpected happened in the small town of Meteets, Wyoming. A ranch dog appeared at a home carrying in its mouth a small animal. The owners, puzzled by its shape and the dark markings on its face, contacted wildlife officials. When biologists arrived, they confirmed what no one believed possible. The animal was a black-footed ferret. The next night, researchers set out across the ranch land with flashlights and careful steps. Their beams of light swept across the grass, catching only moths and the occasional glimmer of dew. Then, near a cluster of prairie dog mounds, a pair of eyes glowed faintly in the dark. A ferret lifted its head above the entrance of a burrow, staring back with a quiet intensity. Soon, more ferrets emerged, moving with the graceful, wriggling motion that had defined their species for generations. The black-footed ferret was alive. Against every expectation, a small population had survived in this hidden corner of Wyoming. The discovery carried both joy and urgency. The population was tiny. Disease and habitat loss still threatened its survival. Without immediate action, the species could vanish again, this time for good. Wildlife officials began a careful rescue effort. Over the next few years, they captured the remaining ferrets from Meeteetse to create a managed breeding program. Only 18 animals formed the foundation of this last chance attempt. The work was delicate. Captive breeding is far from simple. Ferrets needed specific diets, enrichment, and careful handling to encourage natural behaviors. But slowly, new kits were born. The population grew. By the 1990s, the first reintroductions began. Young ferrets were released into protected prairie regions, where prairie dog towns had been restored. Some explored with curiosity, others hid in burrows for days before emerging. Each release carried both risk and promise, a reminder that nature rebuilds with patience rather than speed. Over time, the reintroduction efforts expanded across several states. Scientists monitored populations, managed disease outbreaks, and worked with local communities to protect the lands that the ferrets needed. The sight of a slender, golden body slipping into a burrow once again became part of the prairie night. Then, in 2021, the story expanded in a way that belonged not only to conservation, but to the frontier of science. From frozen tissue preserved decades earlier, researchers produced the first cloned black-footed ferret. Her name was Elizabeth Ann. She was genetically distinct from the limited breeding population, offering a new thread of diversity for a species that had once stood on the edge of disappearance. Elizabeth Ann's birth represented a quiet shift in our understanding of what might be possible. It showed that frozen DNA, preserved carefully in the past, could one day help strengthen species that struggle with genetic bottlenecks. It opened a door to new conservation tools that blend biology with careful ethical thought. Today, black-footed ferrets live in the wild once more. Their populations remain vulnerable. Disease still casts long shadows across the prairies, but their presence, their movement through old tunnels, and their soft nighttime calls remind us of the power of persistence and the outcomes possible when human care aligns with the resilience of nature. As we drift onward from the grasslands, the lingering image is gentle and hopeful. A small ferret peering out from a prairie dog burrow, its dark mask framed by the soft glow of dusk, a creature once lost twice over, now moving forward through restored landscapes, carrying within its lineage both ancient instincts and the quiet touch of scientific care. From the quiet prairies where a slender ferret stepped back into the world with the help of science and patience, our journey turns toward the mountains of southern Europe. The land rises gently at first, then sharply, gathering itself into great slopes of stone and snow. The air grows cooler, pines cling to rocky ledges, valleys open like soft pockets between the peaks. This is the Pyrenees, a rugged stretch of mountains that forms a natural border between France and Spain, shaped by ancient glaciers and winds that whisper through narrow passes. For centuries, these mountains were home to a wild goat known as the Pyrenean ibex. It was a sturdy creature with curved horns and a thick coat that protected it from winter cold. It moved with ease across cliffs that seemed almost vertical, finding safety in places where predators could not follow. The ibex lived in small groups, grazing on mountain grasses and slipping into the shadows of rocks when storms rolled in. But the century was not kind to this species. Hunting pressure increased, habitat shifted, disease spread, and slowly the ibex population dwindled. By the 1980s, only a handful remained. Conservationists tried to save them, but the decline had begun long before their efforts could take hold. In the winter of 2000, the last known Pyrenean ibex, a female named Celia, was found lying beneath a fallen tree. With her passing, the species was declared extinct. Yet Celia's story did not end on that cold winter day. Before she died, scientists had taken small samples of her tissue and preserved them carefully in liquid nitrogen. These samples were not simply memories, they held her DNA, the full blueprint of her body, a complete map of a species that no longer existed. In the years that followed, a group of researchers began to explore a question that hovered between curiosity and bold ambition. Could an extinct species be brought back to life? Cloning was still a developing field, but the idea of using preserved DNA to recreate an animal had captured the imagination of many. The Pyrenean ibex became a candidate for one of the first attempts at de-extinction. The process would be delicate and complex. Celia's DNA had to be inserted into the egg cells of a closely related species. These eggs then had to be implanted into surrogate mothers capable of carrying the pregnancy. Every step carried uncertainty. Every success opened new questions. Years passed as the experiments continued. Most attempts failed early. Some embryos did not survive. Others developed only partially. But in the year 2009, after many trials, something extraordinary happened. A clone of the Pyrenean ibex was born. It was the first time in history that a species declared extinct had returned to life. Even for a brief moment, the young ibex took its first breath. Its small body rose and fell. For 7 minutes, it lived. Then, due to a lung defect that could not be repaired, it slipped quietly away. 7 minutes. Long enough for scientists to confirm success. Long enough to introduce new questions. Long enough to remind the world that resurrection, even when possible, is fragile. Those minutes carried a gentle but powerful message. They showed that science could reach into the past, but not without limits. They revealed the fine line between innovation and risk. The ibex's brief life reminded researchers that cloning cannot restore a species in the same way conservation can protect one. It cannot repair lost habitats. It cannot recreate social structures built over generations. It cannot revive a lineage if only a single set of genes remains. De-extinction, as much as it inspires imagination, must be approached with humility. Celia's clone underscored that bringing back an animal is not the same as saving a species. It also asked a deeper question. Should we devote our energy to reviving what is gone, or to protecting what still breathes quietly around us? At the same time, the experiment opened new doors for science. The techniques refined during the ibex project now help endangered species by preserving genetic diversity. They help maintain frozen libraries of DNA that might one day support populations on the brink. They encourage us to think carefully about what is possible and what responsibilities come with that possibility. Today, the Pyrenean ibex remains extinct. The mountains where it once lived continue to echo with the calls of other animals, but not with the sound of its hooves on stone. Still, for 7 minutes, one small ibex returned, not as a miracle and not as a perfect answer, but as a moment of reflection. As we drift onward from the Pyrenees, the image that lingers is soft and fleeting. A newborn ibex lying gently in straw, breathing mountain air for the first and last time. A reminder that life is fragile, that science is powerful, and that the line between success and hubris is often drawn in moments, as brief as a single breath. From the quiet mountains of the Pyrenees, where a vanished ibex breathed briefly again through the hands of science, our journey turns toward a horizon shaped not by forests or oceans or grasslands, but by questions. The world beneath us becomes softer, fading into a gentle blur as we drift into the realm where biology, imagination, and responsibility weave together. Here, the landscapes are made not of stone or soil, but of ideas. Some are bright with possibility, others are shadowed by caution. This is the frontier of de-extinction, a field that asks whether the creatures we have lost might one day return, and whether we should invite them back. The work begins in places colder than any mountain. Deep within, secure vaults and freezers cooled to temperatures far below winter frost, scientists store tiny fragments of life. These samples are often collected from museums, field expeditions, or remains preserved long before anyone imagined their future use. Inside each sliver of tissue lies a map, written in DNA, containing the instructions for building a body, repairing cells, and guiding the rhythms of life. Frozen DNA is fragile. Time breaks it, heat unravels it, but in some cases, enough pieces remain to offer a starting point for science to explore. These fragments can be read, compared, and assembled into sequences that resemble the genomes of species long gone. When paired with modern genetic tools like CRISPR, researchers can begin to insert, adjust, and refine these sequences within the cells of living relatives. Each step is delicate. Each discovery brings a mixture of excitement and hesitation. Among the most well-known de-extinction projects is the effort to revive something resembling the woolly mammoth. Frozen in Siberian ice for thousands of years, mammoth remains still hold fragments of DNA that whisper of tundra winds and ancient migrations. Scientists compare these fragments with the genome of the Asian elephant, the mammoth's closest living relative. Through CRISPR, they attempt to insert mammoth traits into elephant cells, creating embryos that might one day produce animals capable of surviving in cold northern environments. These creatures would not be true mammoths in the pure sense. Instead, they would be hybrids, shaped by both ancient DNA and modern biology, perhaps able to support ecosystems that once depended on large grazers. Another project focuses on the passenger pigeon, once the most abundant bird in North America. Flocks darkened entire skies, moving like living clouds. Their disappearance in the early 20th century still echoes as one of the most dramatic losses in recorded history. Scientists now examine preserved specimens held in museums, comparing their DNA with the genes of closely related pigeons. The goal is to create birds that behave and function as passenger pigeons did, helping restore the forests they once shaped through their immense numbers. Far to the south, in Australia and Tasmania, a different dream unfolds. The thylacine, often called the Tasmanian tiger, vanished in the 1930s. Its striped back, dog-like posture, and pouch made it one of the world's most unusual mammals. Now, researchers study its preserved tissues, reconstructing its genome piece by piece. The thylacine's closest living relative is the numbat, a small insect eating marsupial. By merging their genetic material, scientists hope to create an animal that fills the ecological role the thylacine once held. These stories read almost like myths, yet the methods behind them are real, grounded in decades of research. Cloning, embryo transfer, gene editing, and stem cell science form a toolkit that grows more refined each year. What once seemed impossible now sits close enough to touch, like a shape behind a thin curtain. Still, the work carries shadows. Even as de-extinction advances, debates unfold quietly in the background. Some scientists argue that bringing back lost species could help restore damaged ecosystems. Mammoths might trample down shrubs in the Arctic, encouraging grasslands that store carbon. Passenger pigeons might once again disperse seeds through forests. Thylacines might help control invasive predators. Others ask a more cautious question. If we focus on resurrecting what is gone, do we risk neglecting what remains? Many species alive today stand at the edge of decline. Their habitats shrink, their numbers fall, their futures depend not on gene editing, but on protection, space, and patience. Conservation resources are limited. Each dollar spent on de-extinction is a dollar not spent preserving living species. There is also the question of responsibility. If we bring an animal back into a world that has changed, can it survive? Can it find food, shelter, and safety? Can it raise young? Will it suffer? These questions are tender and complex, shaped by ethics as much as by science. De-extinction is neither miracle nor mistake. It is a conversation unfolding slowly across laboratories, classrooms, and quiet field stations. It asks us to reflect on our past and imagine our future. It asks us to consider what it means to repair, what it means to create, and what it means to care for the living world. As our journey moves gently forward, the image that lingers is soft and thoughtful. A strand of DNA glowing under a microscope, an elephant cell carrying a memory of fur and frost, a pigeon embryo developing in a warm shell, possibilities held lightly in human hands, not answers, only questions, and the quiet hope that whatever choices we make, they will be guided by humility, wonder, and a deep respect for the fragile miracle of life. From the glowing laboratories where strands of ancient DNA guide scientists into the uncertain future of de-extinction, our path turns once more toward the living world itself. The horizon grows wide and soft. The hum of machines fades away. In its place rises the steady breath of wind, water, forest, and stone. Here, Earth reveals something older than any experiment, something woven into its geology and its silence. This is the story of isolation and of the sanctuaries it creates, places where life endures, not because it is strong, but because the world around it has remained untouched long enough for survival to take root. Our journey begins far beneath the waves. Humans have mapped coastlines for centuries, yet the deep ocean remains mostly unknown. Light fades quickly once it passes through the surface. Within a few hundred meters, colors disappear. Within a few thousand, the world becomes pitch black, quiet except for the distant rumble of underwater mountains and the slow drift of currents older than continents. In this darkness, life takes shapes we rarely imagine. There are fish with bodies that shimmer like scattered stars. There are crustaceans that move without sound, relying on touch more than sight. There are corals older than entire civilizations, growing a fraction of a millimeter at a time. Many of these species exist only in small regions, suspended between pressure and temperature in delicate balance. Some may have remained unchanged for millions of years, protected by the ocean's depth and silence. Every so often, a submarine or deep-sea rover catches a glimpse of something entirely new. A squid with transparent skin, a jellyfish that glows in shades of blue, a fish that swims like a drifting leaf. These sightings remind us that the deep ocean is not barren. It is one of Earth's greatest sanctuaries, a place where countless species wait quietly for discovery. The next sanctuary rises from the sea in the form of volcanic islands. These places begin as bare stone, shaped by eruptions that push molten rock upward from Earth's interior. At first, they seem lifeless, but over time, wind carries seeds from faraway continents. Birds land briefly and leave nutrients behind. Waves bring driftwood and fragments of plants. Slowly, an ecosystem forms. On islands that remain isolated long enough, evolution begins to branch in unusual directions. Animals grow larger or smaller than expected. Birds lose their fear of predators that never arrive. Reptiles adapt to limited food by changing their diets, their colors, or their behaviors. Each island becomes a laboratory of life, shaped not by human hands but by time, distance, and chance. Many of the creatures we have already met in our journey belong to these island sanctuaries. The pink land iguana hidden on the slopes of Wolf Volcano, the giant bee of Indonesia living unseen in a hollow tree, the Lord Howe Island stick insect found again on a volcanic spire rising sharply from the Plasprey Pacific. Their survival was not luck alone. It was isolation, a quiet barrier that shielded life while the rest of the world changed around them. From islands, our path turns upward to high mountains. Their peaks rise above cloud lines, where winds howl and temperatures drop swiftly with nightfall. These heights create worlds within worlds. Valleys are cut off by cliffs. Species climb in search of food or shelter, becoming separated from one another by ridges and glaciers. Over thousands of years, isolation reshapes them. Birds develop new songs. Mammals adapt their coats to the cold. Plants grow low to the ground, sheltering themselves from thin air and harsh sunlight. In these hidden pockets of altitude, life persists quietly. The mountain pygmy possum slept through ages beneath snow. The Kashmir musk deer vanished from sight, only to reappear among high forests shaped by silence. The Pyrenean ibex rested on cliff sides, so remote that only a handful of people ever saw it alive. These creatures remind us that isolation is often both a risk and a refuge. It protects, but it also hides, making survival a delicate balance between solitude and vulnerability. As we trace these sanctuaries across Earth, a deeper truth comes into view. We have explored only a small portion of our planet. The deep ocean remains largely unmapped. Many mountain valleys have never been surveyed. Cave systems twist beneath our feet like forgotten veins of stone. Dense forests still hold species unknown to science, moving just beyond the reach of our eyes. Even on continents we call familiar, there are patches of wilderness where no one has walked in generations. Every rediscovery, from ancient frogs to desert parrots, reminds us that our understanding of Earth is incomplete, not because life hides intentionally, but because the planet is vast, layered, and full of corners where human presence is rare. These sanctuaries do not exist for our curiosity. They exist because life, given time and space, finds ways to endure quietly. As our journey through these hidden places softens to a close, the images that linger are simple and gentle. A tiny creature resting beneath snow, a reptile basking on a volcanic stone, a fish drifting in the dark where sunlight never reaches. Each one carries the same quiet message. The world is deeper than we know. Life is more patient than we imagine. And in the soft spaces untouched by noise or haste, species wait, moving to rhythms older than our understanding. These sanctuaries are not museums. They are living worlds, and they remind us that to understand Earth, we must appreciate not only what we see, but all that remains unseen, waiting softly in the shadows. From Earth's hidden sanctuaries, where life waits in deep oceans, high mountains, and volcanic shadows, our path turns towards something quieter. It is not a landscape this time, but a way of seeing the world, a way of listening, a way of knowing. Scientific discovery often shines brightly, Yet it does not begin in laboratories or with satellite maps. It begins in the footsteps of the people who live closest to the land, people who rise with the same rhythms as the birds, who travel the same forest trails day after day, who learn, through generations, how creatures move, hide, feed, and survive. This kind of knowledge is older than written science. It does not come from textbooks or field guides, but from memory, observation, and stories passed gently from parent to child. In many rediscoveries throughout history, it was this quiet knowledge that carried the first clue. We drift now toward the Solomon Islands, a chain of emerald islands scattered across the Pacific Ocean like beads on a blue thread. The forests here are dense and warm, wrapped in a soft mist that rises each morning from the sea. Leaves glisten, insects hum. At night, the air thickens with the fragrance of flowers that open only in darkness. Long before scientific teams arrived, the islanders spoke of a bird called the Makira woodhen. To them, it was not a mystery. It lived in the underbrush, they said, avoiding clearings and moving in quick, shadowy steps. But scientists, unable to find it during earlier surveys, had declared the bird extinct. The islanders continued to describe it, but their words drifted unheard across oceans. Decades later, a new team visited the islands. They listened to the local guides, followed their descriptions, and walked the narrow shaded paths that only the islanders knew. Deep in the forest, they finally saw it. The bird stepped out from between two tree roots, as if emerging from an old story. It was alive, just as the people had always said. Farther west lies Papua New Guinea, a place where mountains rise straight from the sea and forests grow so thick that even sunlight seems to take its time passing through. Many of the people who live here know their land intimately. They can identify the calls of dozens of birds, track insects by the faint marks they leave on bark, and sense changes in weather hours before clouds appear. For years, scientists searched unsuccessfully for a tiny bird called the mayor's forest rail, but in villages surrounded by thick jungle, people spoke of a shy bird that ran along the forest floor, keeping close to streams and avoiding open ground. They described its size, its coloring, its habits. When scientists followed these descriptions, they finally found it. The bird had been there all along, hidden not by its rarity, but by the narrowness of the search. Even in the vast Congo basin, where trees stretch so high that their crowns form a ceiling of green, local observations play a central role. Here, forest communities have names for hundreds of plants and animals, each one tied to a use, a behavior, or a season. Their knowledge is a kind of map, not drawn on paper but carried in the mind. One of the most famous rediscoveries in Africa began not with scientists, but with hunters who described an animal that looked like a forest antelope, yet walked with the stride of something else entirely. Their descriptions led researchers to the okapi, an animal now known internationally, with striped legs and a gentle face. Without local guidance, its discovery might have taken many more decades in the dense, labyrinthine rainforest. Again and again, these stories reveal the same truth. The world's most hidden species are rarely unknown to the people who share their habitats. The creatures that science loses, local communities often remember. The birds that vanish from field guides still call through valleys known to families who have lived there for generations. The animals declared extinct. Academic papers sometimes continue their quiet lives in regions where the land itself is an old friend. This does not diminish the value of science. Instead, it reminds us that understanding grows stronger when knowledge flows in both directions. When scientists listen, when local voices guide the search, when unfamiliar footprints on a trail are understood not as mysteries, but as part of a story already known. Indigenous knowledge is not static. It adapts, It refines itself. It is shaped by daily encounters with the living world. While scientific surveys may last weeks or months, local observation spans lifetimes. Many rediscoveries, even famous ones, began not with a chance sighting by a researcher, but with a sentence spoken quietly by someone who knew the land better than anyone else. Sometimes it sounds like, "I saw that animal near the old stream." Other times, "My grandfather told me where they feed at night." Simple words, carrying decades of memory. As we drift away from the Solomon Islands, Papua New Guinea, and the Congo Basin, a gentle pattern emerges. Rediscovery is rarely the work of one person or one approach. It is a collaboration between tools and traditions, maps and memories, data and stories. Science, at its best, does not arrive to correct local knowledge. It arrives to join it. The thread that binds these stories together is not technology or theory, but humility, the understanding that the living world is too vast for any one perspective to capture, the knowledge that discovery, in its truest form, begins with listening, and in the soft spaces where people and their land move together, life continues to whisper its secrets. From the islands, mountains, and forests where local memory guided the return of lost creatures, the story drifts into a quieter place. It is not a landscape on any map, it is a space shaped by our own assumptions, built from silence, gaps in knowledge, and the comforting illusion that if something important had survived, we surely would have noticed. It is here, in this gentle but unsettling territory, that disappearance is often mistaken for an ending. This is the realm of false extinctions, moments when a species vanishes not from the earth, but from our sight. The idea begins with something almost too simple. Humans, even with satellites, field tools, and carefully drawn maps, see very little of the living world. Forest floors are hidden beneath deep layers of leaves. Rivers shift their courses through seasons of drought and flood. Mountains cradle valleys that few people have ever entered. And far below the blue surface of the ocean, light fades into a darkness where almost everything can hide. Within these places, creatures learn to move quietly. They slip between shadows, change their habits, or retreat to safer corners of their landscapes. Their survival depends on staying unseen, and often their strategies outlast our patience. For a long time, scientific understanding leaned heavily on direct observation. If a creature was not seen for years or decades, especially in a region where it once lived, it was easy to believe it had disappeared entirely. Reports were drafted. Names were marked with solemn certainty. The word extinct made its way into books, collections, and museum drawers. It felt neat, clear, comfortingly final, yet nature has never been concerned with our need for final answers. A false extinction often begins with the narrowness of human perspective. A researcher surveys a known habitat. No sightings occur. No footprints are found. No calls echo through the trees. Over time, the absence becomes a conclusion, but animals do not stay confined to the borders we assign them. A creature that once lived in a familiar valley may wander into another just beyond the limits of a survey. Food sources change, weather patterns shift. A population that seems to vanish may simply be following its own quiet logic. Sometimes the misunderstanding grows from bias, even unintentionally. We search for an animal where we think it should be, not where it might have learned to hide. A bird, expected to nest beside rivers, may take refuge among cliffs during unusual seasons. A mammal once seen feeding in open fields may retreat into thicker undergrowth after generations of disturbance. When expectations harden into assumptions, and assumptions turn into conclusions, an entire species can be erased with the stroke of a pen. In other moments, the error lies in the rhythm of time. Scientific expeditions are short. The life of a species unfolds across centuries. Some creatures appear only during precise windows, like the brief stillness before dawn or the dry weeks between seasonal rains. If a survey arrives in the wrong month, or even the wrong hour, an entire population can pass undetected. A year of absence means little to a lineage that has weathered countless cycles of heat, storm, and silence. There is also the simple truth of limited data. Many corners of the world remain difficult to reach. Conflict zones, jagged peaks, deep offshore currents, and dense jungles keep researchers at a distance for decades at a time. While science studies what is accessible, life continues in its own secluded chambers, undisturbed by our uncertainty. These mistaken endings reveal something humbling about human perception. They show that not seeing is not the same as not existing, and that the absence of evidence is rarely evidence of absence. The natural world does not step into the open merely because we arrive with notebooks and cameras. It reveals itself in its own time. Throughout this journey, many creatures have carried the weight of false extinction. The takahe walked through quiet mountain grass while the world believed its story had closed. The night parrot whispered through desert winds long after science wrote its name into history books. The Chacoan peccary rooted through thorn forests while its species existed only in fossil collections. Each return offered the same gentle correction, reminding us that life is never as small or as simple as our records suggest. These moments also reveal the emotional gravity behind scientific declarations. Once a species is marked extinct, protections weaken, funding thins, attention drifts elsewhere. Rediscovery becomes more than an exciting moment. It becomes a reflection on how careful we must be when announcing endings that nature itself has not confirmed. There is a softer lesson hidden in all of this. False extinctions show that survival is often quiet. Many creatures adapt not with dramatic changes, but with patience. They shift their habits, sharpen their instincts, or retreat deeper into the folds of their landscapes. They wait for disturbances to fade. They persist in the gentle spaces between our assumptions. As this understanding settles, a calm image rises, a small animal breathing in a place no one thought to search. Its presence steady, almost shy, yet undeniably alive. A reminder that life does not vanish simply because we stopped looking. Across the long path we have traveled, from oceans older than memory to hidden forests and volcanic cliffs, a gentle pattern begins to unfold. It rises slowly, like a shape forming beneath still water. Each rediscovery, no matter how distant or surprising, carries threads that weave softly together. Threads of survival, threads of patience, threads of life doing what life has always done, even when we are not there to witness it. When we look closely, we begin to see that the creatures who returned from the quiet edges of disappearance share certain qualities. Not the dramatic traits we often imagine, but the quiet ones that help life endure in the shadows. Adaptability is one of these threads. Many of the beings we have met changed their habits just enough to survive. A bird that once nested in open valleys learned to hide within cliffs. A mammal that relied on familiar food sources shifted its diet as the world around it transformed. A reptile waited out storms, not by resisting from them, but by folding into the landscape until the danger passed. Adaptability is often gentle, not loud. It does not call attention to itself. It is the soft rearranging of a life so that it may continue. Isolation is another thread, not as a burden, but as a refuge. Many creatures survived in places where human footsteps rarely fell. Remote islands acted like natural vaults, preserving lineages that might have vanished on continents. Mountain ridges held pockets of cool air and shelter. Deep oceans protected ancient species beneath blankets of darkness. Isolation, in these stories, is not loneliness. It is a quiet shield, a space where the world's noise and pressure cannot easily intrude. And there is patience, a kind of patience that belongs only to nature. Some of the beings we rediscovered had survived countless seasons by slowing their rhythms. They hibernated through harsh winters or retreated during difficult decades. They endured droughts by waiting for rains that might come once in a generation. Their patience was neither passive nor desperate. It was steady, like the way seeds rest in soil until the right warmth arrives. Together, these patterns reveal something deeper than individual survival stories. They show that extinction, the word that feels so final and heavy, is often more complex than it first appears. Science, with its careful methods and long observation, has always sought clarity. Yet rediscoveries remind us that the boundary between existence and disappearance is softer than we once believed. Extinction, as written in books and scientific checklists, has long been treated as a moment. One day a creature is part of the world, and the next day its name is followed by silence. But these returns show us that life does not follow such neat lines. A species can vanish from our awareness, yet continue to breathe in the folds of a landscape we rarely visit. It can step outside the frame of our knowledge without leaving the Earth's story. Rediscoveries gently revise our understanding of what extinction truly means. Instead of a single event, it becomes a spectrum, a space of uncertainty, a reminder that our tools, our timelines, and even our expectations can never fully capture the vastness or subtlety of the natural world. Extinction is sometimes real, yes, but sometimes it is a mirror reflecting our limitations rather than nature's endings. There is an emotional truth woven into this as well, one that grows stronger the more we walk through these stories. The creatures that returned did not do so with triumph or fanfare. They were not waiting to be discovered. They were simply continuing their quiet lives, unaware that the world had already written their eulogies. Their return reminds us that life does not surrender easily. It bends, it hides, it shifts its shape, and sometimes it survives in forms we would never think to expect. This understanding reaches beyond biology. It touches a gentler place inside us, the place that recognizes endurance not as a loud declaration, but as a soft persistence. These returns teach us that survival is rarely about strength alone. It is about patience, about knowing when to retreat and when to move, about finding safety in the margins. They also show us that the world is far more alive than we give it credit for, that somewhere, in a desert hollow or beneath a canopy of ancient leaves, life might be continuing in ways we have yet to imagine. These rediscoveries are not just scientific surprises, they are reminders that the earth holds stories we are still learning how to hear. As the thought settles, a simple image forms, a creature breathing quietly in a hidden corner of the world, continuing its lineage while no one is watching, not seeking attention, not fighting for recognition, simply living. Life, in its patient and resilient way, never truly gives up. As the long path of rediscovered lives begins to settle behind us, the world opens into a soft and endless horizon. The forests grow quiet, the oceans breathe in slow, steady pulses. Even the mountains seem to exhale, their ridgelines sinking into dusk. After traveling through deep valleys, hidden islands, volcanic slopes, and ancient seas, the earth feels larger than when we began, as if each rediscovery has added a new layer to its voice. The hum of our earlier steps fades gently, replaced by the low and patient rhythm of the planet itself. It is a rhythm older than language, older than memory, older than every extinction we have mourned. In this stillness, something becomes clear. Earth has never stopped speaking. It has only been waiting for us to listen closely enough to hear. Across the quiet landscape, the creatures we met leave faint impressions, almost like echoes. The coelacanth drifting through deep water, the takahe stepping through mist, the giant tortoise crossing warm, volcanic rock. The ancient frogs, the rare birds, the mammals with fossil histories, the insects with wings that barely stir the air. Their stories do not linger as triumphs, they linger as reminders, gentle proofs that life continues in the soft folds of the world, even long after we have written its ending. As we look back, a pattern glows through these stories, not in bright flashes but in slow, warm embers. Each rediscovered species carries a quiet message that never needed words. Life is patient, life is persistent. Life moves through landscapes with a grace that does not ask for recognition. It adapts when it must. It hides when it needs rest. It waits in the places we pass over, trusting the rhythms it has followed for thousands or even millions of years. The more we reflect, the more the idea of extinction changes shape. It has long been a word carved in heavy stone, a final mark in the history of a species. But the returns we have witnessed soften its edges. Extinction is sometimes a truth, shaped by the pressures of time and change. Yet sometimes it is a misunderstanding, a quiet space where knowledge has not yet reached. Earth has never followed our desire for certainty. It has its own scales, its own rhythms, its own ways of holding life together. In the deep sea, creatures survive under pressures that would crush steel. In remote islands, evolution branches in directions that seem almost impossible. In mountains, ancient mammals sleep beneath snow for half the year, waiting for spring that comes late. And in forests thick with shadow, birds move like whispers through the air, living out entire lifetimes unseen. Every rediscovery reveals how much of the planet remains outside our gaze, not because life is trying to hide, but because the world is vast, layered, and full of corners where human steps rarely fall. These living beings do not return for our recognition. They simply continue, carrying their ancestry through the quiet patience of time. When they reappear, it is not with fanfare. It is with a gentle presence, like a candle glowing in a room we thought was empty. A small reminder that the world is full of unseen stories, that wonder still moves through places we have forgotten to consider, that resilience exists in forms that are humble, quiet, and deeply rooted. As the night deepens around this final reflection, the earth seems to lean closer, not to speak loudly, but to share a soft truth through the steady breath of wind across grass, waves against stone, and the distant rustle of leaves. Extinction may be the rule written across geological history, shaping the rise and fall of entire worlds. But every rediscovery is a gentle refusal, a quiet voice from the living earth,